All right, welcome to this video. I am Tutor Post Solutions from Discrete Learning Institute. So in this video, we're going to be looking over a number of questions on set theory. Okay, so we'll start from the roster form. We go to the set builder notation, talk about the power sets and set operations. Okay, so you can see this tutorial sheet that I have here, it has a lot of questions on sets. So I'm going to go over them. So you can see question 1, question 2. We are going to solve all these questions that you're seeing here. Okay, I'm going to solve all of them. So 7, so on set interval notation. Question 9, set interval notation, verifying rows and the like. We're going to solve all these questions. Okay, so I hope by the end of this video, you would have known how to solve questions on the set theory. Okay, so now let's get into the video. Got this question here. The first one is on roster form. Okay, so you're given sets in set builder notation, and then they want you to present them in roster form. Okay, so there are actually two main ways in which we represent sets. Okay, so let me just try to explain a bit the important concept, and then we can go on and actually solve the questions. So there are two important or main ways in which we represent sets. So the first one is what we call as the roster form. Okay, we can represent a set in terms of the roster form, and this is what is most common. So we start learning about the roster form as early as within that grade 1. Okay, we are just listing sets of bananas, and then you have this set where you're listing apples and I mean sets of fruit. I said set of bananas. Okay, like sets of fruits. Okay, so I can say sets of fruits. Okay, and then in this set, I'm just going to put apple. I'll just write the first letter. Apple, I put banana, I put orange. Okay, maybe just those three. So whenever you see a set with these types of brackets here, these guys are called curly brackets. Okay, so the curly brackets and then the elements are separated by commas like this. This is what we call as the roster form. You're just simply listing, okay, the members or the elements of that set. Okay, so an easy example maybe would be this one. If I say set A has the elements 1, 2, 3, 4, and maybe 5. Okay, so whenever you see something like this, just know that that's a roster form. You're representing a set by listing the elements that are contained in that set. Okay, and then another way in which we represent set is what we call as set builder notation. Okay, so the word should not scare you. Okay, set builder notation simply means you are representing a set in terms of a description. Okay, and now that description is not entirely words. Okay, that description has some mathematical uh, flavors being added to it. That's what we call a set builder notation. You are simply representing a set, okay, in a descriptive way, and that descriptive way is like more mathematical, okay, not just describing by words, but letting that description be mathematical. Okay, so you can see all these sets here, okay, these sets here are being represented in set builder notation, okay? They're just simply being described, and the exact elements that are there, we do not know them, okay? This set is just a mathematical description. So set builder notation, you will just be representing sets, okay, in a descriptive way or mathematical description. That's what set builder notation, and all these that are up here are what we call a set builder notation. Okay, so some important parts of set builder notation, I'll write them here. So for example, if I say A is equals to, I put my curly bracket, X, and then I put to my full colony these ones. Okay, so this full colony, sometimes you can also write it as just a straight line like this. Okay, so whenever you see this or a full colony like that, simply means the same. Okay, so I've full colon there, and then let's say maybe I say X is equals to 2n. And then this n is a member of, let's say, the natural numbers like that. Okay, so this is set builder notation. Okay, but how do you read it? Because most students fail to read this. Okay, so you read this as set A. Okay, so let me be writing somewhere there. So set A, and then this first bracket here, we're going to be reading it is a set. Okay, and then this X, we're going to say O X's. Okay, and then this full colon here, we're going to say it means such that. Okay, such that. Okay, such that, and then whatever is here, you just read it the way it is. So, okay, so we're going to say set A, and then this guy will represent is a set of, I forgot of here. So it's a set of, and then this X, you read it as O X's, okay, such that X is equals to 2n, where this n is a member of the natural numbers. Okay, so that's how you read something that is in set interval. I mean set builder notation. Okay, all right. So sometimes this part here that I've written at the end there, where I'm saying n is a member of the natural numbers, can also be put here in front. Okay, like if you look at the question on F, you've seen there where they've said X is a member of that Q, right? So this part here, you can also put it somewhere there. Okay, but in general anyway, if you see something like this, just read it as whatever set is there. Okay, so if there was B here, I would say set B is a set of all X's, okay, such that this to my full colony, okay, X is equals to 2, where N is a member of the what? Of the natural numbers. So that's how you read the set builder notation. So now, what they'll be asking you or testing you on is the ability for you to convert from the roster form to the set builder notation, or from the set builder notation to the roster form. That's all you'll be doing on this concept in set. Okay, you just be converting. They give you an expression in roster form, you write it in set builder notation. They give you set builder notation, you write it in roster form. That's all. Okay, so now for you to fully understand this topic for roster form and set builder notation, you have to know the sets of numbers that we have. Okay, so those are the videos that I was sharing in the group. I hope you watched them. Okay, so the sets of numbers that we have, okay, we have different types of numbers, right? We have different types of numbers. So we have what we call as complex numbers. Okay, you have to know what complex numbers are. Someone is writing on my screen. Let me disable annotations. Okay, so complex numbers, that's the biggest set of numbers that we have. Okay, and then from the complex numbers, we have what we call as real numbers. Okay, so complex numbers, they're the first ones. Okay, they're the biggest, and then you go to the real numbers. So the real numbers will be divided into two. Okay, they will be divided into what we call as the rational numbers. Okay, and the irrational numbers. Okay, and then these rational numbers here. Okay, these rational numbers here will be divided into um one, okay, the integers. So I'll say here integers. No, integers, you represent them by Z like that. Okay, so they'll be divided into integers, and they will also be divided into, okay, okay, I'll just put it here. So we have the whole numbers there, and then from these whole numbers, we have the natural numbers. Okay, so this here is a set of numbers. Okay, and then apart from the real numbers, the complex numbers, okay, we also have what we call as the imaginary numbers. Okay, so imaginary numbers simply meaning we are just imagining a number. Okay, we are imagining that a number exists, but in the actual sense, it does not exist. Okay, so we'll talk more about the complex numbers later, but right now I just want you two guys to focus on the real numbers, okay, which are subdivided into the rational numbers and the irrational numbers. Okay, and then we have this rational number is being divided into the integers, okay, and the whole numbers. And then from the whole numbers, we get what we call as the natural numbers, okay? So for those who watched the video, they will agree with me. We said that the natural numbers are numbers which we call as counting numbers, okay? So the numbers that you can use to count. So they will start at 1, and they will be increasing by 1, just like that, and so forth, okay, to wherever you are going to stop counting from. Those are what we call as natural numbers. So it's very important to know the natural numbers and understand that natural numbers are counting numbers, and they start at 1, and then they keep on increasing by 1 to wherever you're going to end from. Okay. And then also, very important to know are the integers. So the integers are those numbers that you are seeing on the number line. Okay. I'm sure everyone here has drawn a number line before. So we have a number line, we have 0, we have positive numbers on this side, we have negative numbers on that side. So these numbers that we have found on the number line, okay, are what we call as integers. And the integers can never be a decimal number, and they can never be a fraction. Okay, so uh, integers, okay, they will come from wherever they are coming from: -3, -2, -1, and then 0, and then 1, and then 2, 3, and then they'll go wherever they are going. So those are integers, the numbers on the number line. Okay, so make sure there are no fractions, there are no decimal numbers. Okay, the other number that we have to know about, which is important, is the what? Is the rational numbers. Okay, so the rational numbers are simply fractions. Okay, so any number that can be represented in terms of a fraction is what we call as a rational number. Okay, any number that can be represented in the form a over b. So a over b, where this b here should never be equals to 0. That's what we call as a rational number. Okay, so for the other numbers, you can watch that video. It's detailed, but for this one, I think these are enough for us to solve whatever we are seeing here. Okay, so rational numbers, any number that is in form of a fraction, it's rational. All right, so now let's look at the first question there. So if you have any questions, please ask. Okay, so here the first question says, write the following sets in roster form. So roster form, we said it's listing form, right? So now look at the set that they've given me. They've said set A is a set of all x's such that x is even. Okay, by even, I know you know. Okay, by even just means x is an even number. So meaning 2 can go there without leaving a remainder. So x is even, and this same x should be less than 19. And this same x is also a natural number. Okay, this same x is also a natural number like that. So this is set builder notation. So now they want us to turn it into roster form. So we just read the description, understand it, and then come up with a set in roster form. Okay, so here they're saying x, okay, is even. So meaning that we expect that set A should have numbers that will be divisible by 2, right? But there are a lot of numbers divisible by 2. So how do we narrow it down? There's another condition that has been given here. They're saying x is less than 19. Okay, there are a lot of numbers that are even and they are less than 19. So how do we know which one to put in this set? Oh, another condition has been given there. X is a natural number. Okay, so now that one puts us in a confined place. So now we know definitely what to be contained in that set. Okay, so for the natural numbers, okay, what natural numbers are actually less than 19? Okay, we said natural numbers start at 1, then they increase by 1, just like that. So 1, 2, 3, and 2 wherever you are going. But they've said here x should be less than 19. So it means the natural numbers that I'll be interested in here are the natural numbers that are actually less than 19. Okay, so let's just write them on top here. So 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then, yeah, so just those. Less than 19. In fact, 19 should not be there because they said less than 19. Okay, so these are the natural numbers that are actually less than 19. Okay, and then of these numbers, which one do we pick to be in this set? They said x should be what? Should be even. So of these numbers that are less than 19, I'm just going to pick the ones that are even, meaning those numbers that I can divide by 2 without leaving any remainder. So the first one will be 2, okay, 4, 6, 8, 10, 12, 14, 16, and then 18. So these are the numbers that are actually less than what? 19. So they are the ones that are going to be in the set A when we put it in roster form. So I'm just going to say set A is actually equals to, okay, 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so this set here in descriptive form and this set here in listing form is the same. Okay, but the other one is just descriptive way. The other one, we are explicitly listing all the elements that are there. All right, so any questions there on how we've gotten this answer? Any questions there? Okay, right. So there are no questions. Let's move to the next one. I hope Vingena, guys. Okay, I hope Vingena. So the other one here is set B is equals to, okay. Set B is a set of all x's, okay, such that 6 plus x is equals to 5, and x is a natural number. All right, so how do we know the values of x that are going to be part of this set? We just look at the equation that has been given here. Okay, you've seen this equation here. So the equation says 6 plus x should give you 5. Okay, and that x is also a natural number. Okay, so let's see if all those conditions are going to be satisfied. So 6 plus x is equals to 5. And then let me solve for x. So x is actually equals to, this will be 5. And then this 6 goes to the other side like that. So that is minus 6. This will be equals to minus 1. Okay, so this description here gives me that x is equals to minus 1. Okay, but another condition in this description said that x is a natural number. Okay, x is a natural number. And we said that natural numbers start at 1, 2, 3, and then they will continue increasing by 1, just like that, right? Okay, so it means if I was to write this set B in roster form, what would it be? What elements are going to be in set B? Anyone who can try? Anyone who can try? What elements are going to be in set B?
I think since x is equals to -1, it will be an empty set.
Exactly. Okay, so that is an empty set because the equation is giving us a negative number. Okay, but the part of the description was saying x should be a natural number. So it means this is just describing an empty set. Okay, so we're going to say B is an empty set. So we put these symbols like that. Okay, indicating that B, it's an empty. Or you can say B is equals to, you put a 0 and then you cross it. Okay, so these two symbols are the ones that we use to indicate the empty set. But I've seen some students doing this. They say this is an empty set like this. No. Okay, so this one here is not an empty set. If you write this, they're going to mark you wrong. Okay, this is a set that contains the empty set, but it's not an empty set. All right, so this description here leads us to an empty set. So you can see that these mathematicians just like complicating things, right? Imagine an empty set, they're just wasting all the time describing it like this, but it's just empty. Okay, so move on to the third part. Move on to the third part. Okay, so the third part says what? So there's C there. So C is equals to Okay, this is a set of all x's such that x is equals to 3n. Okay, and n is an integer where the modulus of x should be less than or equals to 9. Okay, so now here, pay attention. Okay, so you've seen the description there. Okay, so if you're not careful, you're going to get confused because here they have actually used a notation that is very early um, as you are learning these things. Okay, so the module is supposed to come later, but they have used it in the first topic. So what do we do? So I'll just explain what the modulus is. So you've seen these two lines, the two lines here. These are what we call as modulus or absolute bars. Okay, so what the absolute bars does is that it makes whatever number is in between it, okay, or whatever number is in between them, it makes them positive. Okay, so if I have the absolute bars minus 2 like that, this is the same as positive 2. The absolute bars of 2 is also 2. So it doesn't matter if there's a positive or a negative there, the answer coming out of the bars should always be what? Should always be positive. That's simply what it means. Okay, so now this description is saying x is equal to 3n. Okay, x is equals to 3n. N is an integer. Okay, so if they just say n is an integer, meaning we can use any integer that we want because n is just an integer. Okay, but we are limited. Okay, how are we limited? We're saying for that particular n that we are going to choose as our integer, okay, the value of x that we should get, because you can see that x and n are actually related by this equation, right? So whatever you do to n actually affects x. Okay, so now they're telling us that n is an integer, okay, but that integer n that we pick, we should make sure that it gives us a value of x such that when we take the modulus of that value, is going to be less than or equals to 9. That's what they mean there. Okay, so if I go to the integers, okay, let me just make a small uh, number line here. I have 0, 1, 2, 3, and then it continues to go. Here, minus 1, minus 2, minus 3. Okay, so I'm looking for integers such that when I put them in this equation, it will give me a value of x, okay, such that that value of x, if I take the modulus of it, I'm going to get a value that is less than or equals to 9. Okay, I'm going to get a value that is less than or equals to what? To 9. That's what they mean there. Okay. All right. So there what we're going to do is that we're just going to start from the 0 point, and then we start moving to the left and also move to the right, and then notice what is going to be happening. Okay. So I'll first get 0. So if my n is 0, what will happen to the x? So x will just be equals to 3 multiplied by 0. This will just be 0. Okay, so now if I take the modulus of 0, is it going to be less than or equals to 9? The answer is yes, it's going to be less than or equal to 9. So I'm going to take this as the first or one of the values that I'm going to put in the set C. Okay, okay, I continue going to the right. So what if my n is 1? Okay, what will be my x? So x will be 3 multiplied by 1. So this will just be 3. Okay, so I get x is equals to 3. So now if I take the modulus of that 3, is it less than or equals to 9? The answer is yes. So I'll tick this again. Okay, I move on to n is equals to 2. So if my n is equals to 2, then what would be my x? So that would be 3 multiplied by 2. So that would be 6. Okay, so if I take the modulus of 6, is it going to be less than or equal to 9? Yes. Okay, what if my n is actually 3? Okay, then x will just be equals to 3 multiplied by 3. This will just be 9. Is 9 less than or equals to 9? The answer is yes. Okay, so all these 0, 3, 6, 9, they are going to be part of set C. Okay, let's try to move one step forward. So n is equals to 4. We see what we're going to get. So x here will be equals to 3 multiplied by 4, and this will be 12. So now if I take the modulus of 12, am I going to get a number that is less than or equals to 9? No. The answer is no. So this one, no. Okay, so it means enough of going to the right. Let's go to the left side of, or the other side of 0. So what if my n now is minus 1? Then my x is going to be equals to, okay, 3 multiplied by minus 1, which will just be minus 3. Okay, now when I take the base, the modulus of this minus 3, is it giving me a number that is less than or equals to 9? The answer is yes. So I'm going to say yes, it will belong to set C. Okay, I move again a step to the left, n is going to be minus 2. So x is equals to 3 multiplied by minus 2. This will just be minus 6. Okay, so is the modulus of minus 6 less than or equals to 9? The answer is yes. So we tick this one. N is equals to, move a step again, minus 3. So x is equals to 3 multiplied by minus 3. This is going to give me minus 9. Okay, so now is the modulus of minus 9 less than or equals to 9? Yes, because the modulus of minus 9 will just be 9 itself, which is equal to 9. So I'm going to say yes, this one is going to be in set C. Okay, what about if I move a step again to the left, I say n is equals to minus 4. X will be equals to 3 multiplied by minus 4, and this will just be minus 12. So now, is the modulus of minus 12 less than or equal to 9? The answer is no. Okay, so which values of x are we going to put in the set C? Anyone who can say. You should say them in order of how we should write them.
It would be negative 9, comma negative 6, negative 3, comma 0, comma 3, comma 6, and 9.
Comma 3, comma 6, comma 9. Okay, so exactly. So these are the elements that are going to be in set C. Okay, so you just play with whatever they are describing, and then you'll find the set that they want you to list. Okay, so imagine if you don't know what the integers are. How are you going to answer the question? There will be no way you answer the question. So no wonder I explained first, Paja, Kuti, the integers are these and these. Okay, so you have to know the set of the numbers. All right, so any questions there, guys? Any questions? So far, so good? Okay, let's
Why
continue.
not
Huh?
the 12, negative 4?
At why not what?
Why can't we include negative 12?
Okay, so we can't include negative 12 because when we get the modulus of minus 12, we are going to get a positive 12. Okay, so here the condition says if we get the modulus of that certain x value, should be less than or equal to 9. But we see that 12 is not less than or equal to 9. It's actually greater than 9. No wonder we can't include it there.
Oh, thank you.
Yes. All right, let's look at the next one, which is D. Okay, let's look at D. So on D, they're saying what? Okay, so D is a set of OXs such that X, oh, no, they didn't write it like that. So they said set D is a set of X, which is a natural number, okay, such that X squared is less than 20. Okay, this one should be very easy. So here they're just telling us that X, okay, X is a natural number. Okay, and then when I get this value of X, which is a natural number, and I square it, I should get a value which is less than 20. Okay, so if you want, you can just list maybe the first 5 or 6 natural numbers. Okay, so the first 5 or 6 natural numbers, let me list them here. That's going to be 1, 2, 3, 4, 5, and then 6. Okay, so these are the first 6 natural numbers. So now this set D is going to contain those numbers such that when I square them, they're going to give me a number which is less than 20. So I'm just going to start squaring these guys. So 1 squared gives me 1. 2 squared gives me 4. 3 squared gives me 9. 4 squared gives me 16. And then 5 squared gives me 25. Okay. I think we can even end there. Okay. So now you start asking yourself, is my 1 squared less than 20? Yes, it is. So it means this guy is going to be in set D. Okay. Is my 2 squared, which is 4, less than 20? Yes. So it's going to be in the set D. Is my 3 squared, which is 9, less than um, 20? Yes. Is my 4 squared, which is 16, less than 20? Yes. Is my 5 squared, which is 25, less than 20? No. Someone almost said yes. Okay, so no, it's not. Okay, so it means that we've found our set D. Our set D is just going to contain those numbers such that when we square them, uh, what we get is actually less than 20. So it means that my set D is going to be 1, 2, 3, okay, and then 4. So this is my set D here. Okay, as simple as that. Okay, so just follow the description and then you'll be okay. All right, so if there are questions, I move to the next one. So the next one says what? Is that supposed to be a square on the x? I presume so. So here on E, they are saying, okay, it's a set of all x's where x is an integer, okay, such that this one here should be x squared, such that x squared minus 5x plus 6 is equals to 0. Okay, so they want us to list this set here. Okay, so meaning that uh, the values of x that should be in this set should be able to satisfy this equation here. Okay, and those values of x should also be what? Should also be integers. So how do we find the values of x that are going to be in this set? We simply solve this quadratic equation here. Okay, so remember from secondary we used to say product, factor, sum. It's the same thing that you're going to apply there to just solve for the values of x. And those values of x are the exact thing that are going to be part of that set. So we're going to say, okay, x squared minus 5x plus 6 is equals to 0. Then you say product, factor, and then the sum. Okay, so the product, okay, the product is when you multiply the coefficient of x squared with the constant, which is 6. So 1 multiplied by 6, I get 6. The sum is the coefficient of x, so minus 5. Okay, and then the factors, you're just going to look for 2 numbers. Okay, you look for 2 numbers such that when you multiply them, okay, when you multiply them, you get positive 6, but when you add them, you get minus 5. So what are those 2 numbers? Anyone who can try?
-3, -2.
Yes, okay, as simple as that. So you put here -2 and then -3. You can see when I add them, I get minus 5. Okay, when I multiply them, I get 6. Okay, so later on, we'll talk about quadratic functions or quadratic equations in full details. Okay, in full details, and it's a very nice topic. Learn about how to solve them, how to graph them, everything about quadratics. All right, so here I'm just going to say x squared, and then this 5x here, okay, I'm going to represent it in terms of the factors. So I'm going to write minus 2x minus 3x in place of the minus 5x, okay? Then I'll continue with the plus 6 is equals to 0. So you've seen I haven't changed anything. I've just written this guy as minus 2x minus 3x. Okay, so here now I'm just going to group like that. Okay, and then I ask myself, what is common here? Okay, what is common there is x, because this has x squared, this is minus 2x. So x, then what will remain there would be x, there minus 2. Okay, what is common here? Okay, so when getting what is common here, your aim is to make whatever will remain in the brackets the same as this. Okay, so how can I do that? I'm going to factorize a minus 3. So that will be minus 3. I remain with the x. And then here, for it to be positive, it means I have to have a minus there and then 2. So you can see minus 3 multiplied by x, I get minus 3x. Minus 3 multiplied by minus 2, I get back my positive 6. Okay, so that's what I wanted, is equals to 0. So now here you can see that whatever is in the bracket is the same. So you write it once. Okay, and then you combine whatever was outside there, which is x minus 3 is equals to 0. And then from here, you equate each of these to 0 and then solve for x. So the first one, just give me x is equals to 2. The other one, just give me x is equals to what? To 3. Okay, so that is what I get there. So meaning that in this set E, I only have 2 elements. So the elements that I have there, or members, will just be 2 and 3. Because the solutions to this equation there, and 2 and 3 are also what? They're also integers. All right, so we just have 2 and 3 in that set. So any questions there? Okay, so if there are no questions, I think let me solve one more on the roster form, and then we go to the one where we're converting from the roster to the set builder notation. So that one now it's interesting. Okay, because here they are describing for you, you're just simply listing them, but now they have listed and then they want you to describe. Okay, so that is more interesting than this. So here they've said f is actually equals to this. Okay, x is a rational number, okay, such that x is equals to 2n plus 1 over n plus 2. And then what now? Okay, n plus 2, and then n is an integer. I mean, it's a natural number. And this natural number should actually be less than 5. Okay, all right. So by this description here, we can see that x here is a rational number. So meaning x is actually a fraction. Okay, it's actually a fraction. All right, so now how do we find the members that are going to be a part of set F? We just follow the description. So first of all the values of x that are to be a part of this set, okay, should follow this formula. Okay, and from this formula, they have said n is a natural number and n is less than 5. So which natural number is actually less than 5? So I'll just write the natural number that are less than 5 here. It's just 1, 2, 3, and then 4. These are the natural numbers that are less than 5. Okay, so now to find the values of x that are going to be in set F, we're just going to say the first one is when n is equals to 1. So when n is equals to 1, then x will be equals to 2 multiplied by 1 plus 1 over 1 plus 2. Okay, so this is what I have there. So this will just be equals to 2 multiplied by 1, 2 plus 1. And then 1 plus 2, 3. So I'll have a 3 on top and the 3 down. This will just be 1. So the first member of set F is going to be 1. Okay, what about when n is equals to 2? Then x is going to be equals to 2 multiplied by 2 plus 1 divided by 2 plus 2, which will just give me 2 multiplied by 2 is 4. And then plus 1, that is 5. And then down there, I'm getting 4. Okay. All right. What about when n is equals to 3? X will be equals to 2 multiplied by 3 plus 1 over 3 plus 2, which will be equals to. Okay. So on top here, I have a 2 multiplying 3. That is 6. And then plus 1, that is 7, divided by 3 plus 2, that will be 5. Okay, and then the last one will be when n is equals to 4. So x will be equals to 2 multiplied by 4 plus 1 divided by 4 plus 2. So on top, 2 multiplied by 4, that is 8, plus 1, 9. So it will be 9 divided by 4 plus 6. I've said the answer now. So 4 plus 2, that is 6. Okay, so these are the only elements that are going to be in set what? F. So I'm just going now to list it down. So F is just going to be 1, okay, 5 over 4, 7 over 5, and then 9 over 6. This is my set F. All right, so that's how you can convert the set builder notation to the roster form. So simply understand the description, then you are well and good. So any questions there, guys, before we go to the other part?
Question.
Yes. You can ask.
You said x is a rational number, right?
Yes.
And then rational numbers is a fraction. How
Yes.
come here there is 1?
Okay, so so 1, or I should say any number that you see is actually a fraction. It's just that the denominator is 1. So any number, if you divide it by 1, what do you get?
All right.
Yes, so 1 over 1. If you want, you can write it like this. So now this is a fraction, right? So it's the same as 1.
Is it okay if we can also simplify 9 over 6?
Simplify 9 over 6. For roster form, no. You just leave it like that. Because there is a pattern that is following there. You can see like on top, they're increasing by 2, down they're increasing by 1. So just leave it like that for roster form. Don't simplify. Is that okay?
Yes.
All right. Okay, so I'll leave this one, the last one here, G. So G, you can do it at your own time, and then you can share with me your solutions, and then I'll take a look at them if you're doing the correct thing. All right, so I'll move to the next part now. So here you can see we have sets that have been listed now, and we want to describe them. So this part here, that's where we have issues. Okay, that's where we have issues. But the only thing that you need to do to describe a set, okay, is first of all, you identify a pattern. Okay, you identify a pattern of whatever list that they have given you. So is there a pattern in that list that they have given you? So if there's a pattern, then you are well to go. Okay, if there's no pattern, maybe it can be challenging like that. Okay, but mostly we just identify the pattern and then we'll know what we're talking about. Okay, so here we'll be getting these listed things now, putting them in descriptions. Okay, and that description should be mathematical. Okay, not in words. They will mark you wrong. Okay. All right. So is it last semester or the other intake? The other intake, there was a question, they were saying get this set. Okay, they listed the set and then put in set build annotation. And then this student, what they did is that they just wrote at set A is a set that contains, and then they started writing the numbers in words, like the way it is here. -3, so they write -3, -2, -1, and the like. So that is not correct, okay? So you have to describe it mathematically. Okay, so they mean they should be symbols and the like. So the first one here has been given as set P has -3, -2, -1, and then 0, 1, 2, and then 3. Okay, so this is what we have here. Okay, so can we see any pattern or can we notice a certain set of numbers that is appearing there? Anyone who can try?
These are integers.
Okay, so they are integers. 1. Anything to add on? Hello?
Natural numbers or
So
numbers.
you're saying what? Natural numbers?
No, they're not natural numbers, these are integers.
From 1 to 3.
Okay, and Mr. Jasper, what did you say? Hello? I saw Mr. Jasper raising up his hand. Okay, so what she said was true. These are oh, someone is still saying something? Okay, so she said these are integers, right? So these are integers, yes. But if you just say integers, it won't be enough to describe this particular set that we've been given. Okay, so we have to put some like limits to that description of integers. Okay, we all know this is -3, -2, -1, 0, 1, 2, 3. These are integers. Perfect. Okay, but now we have to limit. These are integers, okay, from -3 to 3. Okay, -3 to +3. These are integers from -3 to +3. So now in your set, don't write these are integers from -3 to +3. No, they're going to mark you wrong. You have to represent that in mathematical terms now. Okay, so I'm going to say P is equals to, okay, so it's a set of OXs such that, okay, X is an integer, okay, so this is Z, and this X is actually between -3 and +3. So I'm going to write -3 less than or equal to X less than or equal to +3. Okay, so we have fully described that now in set builder notation. Okay, simply saying set P is a set of all X's such that X is an integer, okay, and this X is between the integers -3 and +3. All right, so as simple as that. If you don't have a question, you can, I mean, if you have a question, you can ask. If you don't have, we'll move to B. Okay, so now let's look at B. So we always identify a pattern, right? Or the type of um, set of numbers that we have. So here we have Q, okay, and then we've been given 1, 4, 9, 16, 25, comma, and then you can see there are these 2 dots like that. Okay, so these 3 dots here, or sometimes they can actually be 4 and the like. They are simply telling you that this set continues to go infinitely. Okay, infinitely. It continues to go infinitely, but mathematicians are too lazy to write all the numbers. So they have just ended at 25, and then they are telling you that, okay, it follows the same pattern until forever. All right, so what pattern can we see in these numbers that are here? And anyone who has noticed a pattern for these numbers?
A set of
I'm
cubes. It's a set of cubes.
A set of what? I said it's a set of,
Numbers.
you said, you said this is a set of cubes.
They
Square
are
number.
squares.
Square numbers.
I think they were squaring even numbers. I mean, natural numbers.
Okay, yeah, so that's the answer. So this is a set of squares, and these squares are actually perfect squares, okay, because they're just squares of the natural numbers. So squares of natural
Yes.
numbers are actually perfect squares. All right, so now how do we write them as a descriptive or set builder notation? Okay, so what we can notice is that the first one here is simply 1 squared. The 4 is simply 2 squared. The 9 is simply 3 squared. And then the 4 is simply 4 squared. This is simply 25 squared, comma. So meaning here, the next one would have been 6 squared, right? 7 squared, and so on. Okay, so now how do you describe this? Okay, so I'm going to say set Q, okay, is a set of all x's such that, okay, such that x is equals to n squared, okay, where the n is a member of the natural numbers. As simple as that. Okay, you are done. You have described that set of the perfect squares. Okay, what about part 3 or part C? So part C, okay, let me write it first. So R, and then they've written 4, 7, 10, 13, 16, 19, and then 22. Okay, so is there any pattern that we are noticing there in this set? Any pattern that we can see?
Yeah, they're adding 3.
Okay, so they're adding 3. Okay. Yeah, so they're adding 3 there, or we can simply say the numbers are increasing by 3. Okay, with 4 being the first member of that set. Okay, and then 22 being the last. So they're just adding 3 to get the other number. Okay, so in your secondary school, this is what you are calling as AP. Do you remember the APs? So arithmetic progressions. This is what they are doing here. Okay, so it might require you to actually recall the two formulas that you are doing in grade 12. So we used to say that the nth term is equals to the first term plus n minus 1 and then multiplied by d. So d, we used to call it as the common difference, remember? Okay, so that's what we are doing here because all of them are actually increasing by 3. So meaning the common difference between two consecutive terms is going to be the same. Okay, it's going to be the same. So we can actually find d. So d is just going to be equals to, we can subtract any consecutive terms here. Okay, so I'll just choose 7 and minus 4. So 7 minus 4 is going to give me 3. So here we have a common difference of 3. And then the first term indicated by A, okay, is going to be 4. So the first term is 4 there. All right, so meaning that here, this is the first term. So we get this, okay, we get this when n is equals to 1 because n represents the position, right? In terms of this formula here. So what I'm going to do there, is that I'm going to represent it in this way. Okay, I'm going to represent it in this way. I'm going to say, here I have Tn, right? Or maybe I can just keep, I can keep the notation to avoid confusion. Okay, I can just keep the notation. So what is changing there? It's what is changing. Oh, okay. Let me write it like this. So what is changing here is actually just this part. You've seen the n minus 1 there. That's what will be changing. Because A is the first term, so it's constant. It will forever be 4 in this set. D, it's a common difference. It will forever be 3 in this set. But n minus 1 will be changing depending on the what? On the element that we are dealing with. Okay? So what if I write this as the first term, T1, is going to be equals to 4. Okay? I want us to drive it step by step. So 4 plus, and then notice what will happen in the brackets. It will be 1 minus 1. And then the D is 3. Okay? So this 1 minus 1 is the same as 0, right? Okay, so this is the same as 4 plus, there I have a 0, and then multiply by 3. Okay? And then the answer there, I'm just going to get 4, which is the first term there. The second term, which is 7 here, it will be T2 is equals to 4 plus, in the brackets, 2 minus 1, 3 is equals to 4 plus, what is in the brackets now? 1. Multiply by 3, I get 7. Which was this 7? How did they get the 10? They said T3, and this was 4 plus 3 minus 1, 3 is equals to 4 plus 3 minus 1, that is 2, and then 3, and this gave them a 10. Okay, so I want you to take to pay particular attention on what is happening in the brackets. And then T4, it is 4 plus 3. Oh, no. plus 4 and then minus 3 multiplied by 3. This will be 4 plus, inside the bracket here it's 4 minus 1. This will be 3 multiplied by 3, and this will just be equals to. So 3 multiplied by 3, 9, plus 4, that will give me 13. That's how I got the 13 there. Okay. What about the fifth guy there with 16? So it was 4 and then plus 5 minus 1 multiplied by 3. So that will just be 4 plus 4 multiplied by 3. And then this will be 4 multiplied by 3, that is 12, plus 4, I get my 16. Okay, so it means to get T6, it will just be 4. I won't even write the other part. I'll just follow the pattern now. To just be 4 plus, okay, plus 5 multiplied by 3. So this is 15 plus 4, 19. T7 will just be 4 plus, this one increases by 1, 6, multiplied by 3. This will be what? 22. So now, you notice what is happening in my bracket. The number is increasing from 0 to 1 to 2 to 3 to 4 to 5 to 6. So the number is increasing by 1. Okay? And these numbers are actually starting at 0. Okay? They're increasing all the way to 6. So in what category of numbers can we put the numbers from 0 to 6? In what category of numbers, or in what sets of numbers can we put the numbers 0 to 6? Hello?
Whole numbers.
Okay, yes. So it's acceptable. We can put them as whole numbers, and also we can actually represent them as integers. Okay, because um, the integers, okay, they're actually just having the negatives of the positive parts of the natural numbers. Okay, so we can represent these as integers from 0 to 6, or we can represent them as whole numbers from 0 to 6. So meaning that this one, you can actually represent it in 2 ways. Okay, you can represent it in 2 ways. So what I'm going to do now to represent this set, I'm just going to write it like this. Okay, so I'm going to set R, okay, is a set of, okay, then we say R is a set of all x's, okay, such that x is equals to, okay, x is equals to 4 plus 3n. Notice I'm just writing 3n there, okay, 3n, where the n is actually an integer, okay, and these integers that we are getting are between 0 and what? And 6. You can represent it like that. Another way, you can write the same way that I've written here, and then here after the comma, you can say n is a whole number, okay? And these whole numbers that we are getting, they are also between 0 and what? And 6. So that's how we can represent that one in roster form. Okay, so any questions there, guys? Okay, let's. Oh, someone has a question. Yes?
Yes.
Yes.
Would it be wrong if we were to present it as R is equal to
Mhm.
X, such that X is equal to n plus 3, where n is a natural number?
Okay, let me just write what you're saying. You said such that x is equals to n plus 3. That's what you said?
Yes, where n is a natural number.
Okay, so now there it would depend on the range of the natural numbers that you've actually said. So what is your range for the natural numbers if you use this one here?
Oh, okay, I see.
Yes. So it can work or it cannot work, but depending on the range of the natural numbers that you've actually picked. So if it works, it means you can also represent it like that. But if it doesn't work, then you can't represent it like that. Okay, someone also has raised their hand. I don't know. This is just IT or something. There's no name.
Okay, my question is on that part where you said n is a member of set of integers. Where is that integers came from?
Okay, so the integers are coming from what was happening in the brackets. Let me be highlighting them. So as we are writing these formulas here, I said pay particular attention of what is happening in the brackets. You've seen the brackets there. So what is happening in the brackets? I have 0, 1, 2, 3, 4, 5, 6. So those numbers in the brackets, that's where the integers are coming from. Okay, so 0 to 6, they are part of the integers. No wonder we put integers there. And 0 to 6 are also part of the whole numbers. No wonder we also put the whole numbers there. Is that okay? The one who asked the question. Hello?
Yeah, I've gotten the point.
Oh, all right, all right, all right. Okay, so that is that about that. Okay, I'll leave D. I'll solve E. Okay, so D here this is just a set of cubes. Okay, so I know you can do that. You can try it at your own, just for practice. Okay, and then I'll do U. So U, let me write it. So U is equals to, 1 over 2, 2 over 3, 3 over 4, 4 over 5, and then 5 over 6, comma, 3 dots like that. So meaning this thing continues to go until forever. Okay, so what pattern can we see on this set? Any pattern that we can see or notice?
The numerators are increasing by 1 and the denominators also increasing by 1.
Okay, yes, that is true. Any other pattern that we can see or trend on these numbers? Come on, guys. Think. Any other pattern that you can see there on this set, on what's happening to the numbers?
The top part is increasing by 1,
The top part
and
is increasing. And
their natural numbers
okay,
on
similar to
the
what
numerator.
the other one said. Similar to what the other one said. I want someone who notice something that I'm seeing. Yes, they're increasing by 1. The numerators are increasing. The denominators are increasing. What other thing can you see? Okay, let me just ask this question. Like, if I just get this term here, what can you notice about that term?
The rational number.
It's a rational number. Okay, it's a rational number. That is true, but it's not what I'm looking for. Okay, I get this 4 over 5. What can you notice about 4 over 5? Come on, guys. I want someone to say it.
Maybe the
I
denominator
think
is
they are
increasing
proper
by 1.
fractions.
Someone said proper fractions. Okay, that's the same as rational numbers. And then the other one was speaking.
The denominator is increasing by 1 each time. I've forgotten the way I wanted to say it. So
But that's what I'm looking for. So that's the answer. So like on each of these fractions, you can see that the denominator is just 1 more than the numerator. So on top I have 1, it means on top I have 1 plus 1. I mean down I have 1 plus 1. On top I have 2, it means down I have 2 plus 1. On top I have 3, it means down I have 3 plus 1. So that's the relationship that I wanted you guys to notice. So it's a very common relationship, okay, and you can even find it in the test. All right, so here we can see that what we have said, okay, the numerators are increasing by 1, the denominators are increasing by 1, and also that the numerator, okay, is less by 1 than the what? The denominator. Okay, and if I look at this number here, the first one, 1, or if I just look at the numerators, you can see that this is just 1, 2, 3, 4, 5. So these are natural numbers, okay? And then even down there, they're also natural numbers, but they're just starting at 2. So to represent this set in set builder notation, I'm just going to say U is equals to, okay, a set of all x's such that x is equals to n over, we said the denominator increases by 1. So it will be n plus 1, okay? And then comma, n should be a what? Should be a natural number. As simple as that. So you represent that set in set builder notation like that. Then you found the answer. Okay. So meaning that if I get my first natural number, which is 1, my x will just be equals to 1 over 1 plus 1, which is just 1 over 2, which is what we have there. Okay. And then the next one to be increasing just like that. So this is a very common question. So make sure you know it. Okay. So any questions there, guys? All right. So let's look at this question now. So the question says, let set x be equals to ABC, y be equals to ADC. Write down in what's the form. Okay, I think we've done a similar question before, right? We've done a similar question before, but let's just do it anyway. So here they're saying write down in what's the form the power set of x and y. So there we just have to know the definition of what a power set is. So we said the power set is just a set that has all the subsets of a particular set. That's what a power set is. Okay. So to write the power set of x, I'll first write my x here, which is A, B, and then C. Okay. This is my power set. And then from there, I'm going to ask myself, how many subsets would this set have? So that is 2 to the power n. Okay, where n is the number of elements there. So 1, 2, 3. So it will be 2 to the power 3, which will just be what? 8 subsets. Okay, so we have 8 subsets there. So now to write the power sets, we're just the power set of this set, we're just going to list all the 8 subsets. Okay, so I'm going to say power set of x is equals to, and then I start listing the subsets from this set. So A by itself, B by itself, C by itself, okay, AB by itself, I pair the A with the B, and then I also pair the A with the C, okay, and then now I pair the B with the C, okay, and then we said a non-empty set will always have at least 2 subsets, right? So the other 2 are the empty set and the set itself. So I'm going to write the set itself here, and then the empty set at the end like that. Okay, so this one here is the power set of what? The power set of x. Okay, and then for the power set of y, we are going to do the same. So it will be y is equals to, y has A, D, C. So you first find the number of subsets. So you do 2 to the power 3, which will give you 8 subsets. Okay, there's 8 subsets. And then we list these 8 subsets to find the power set. We're just going to have A by itself, D with by itself, and then C by itself. And then we have AD. Okay, and then we have AC. And then we have D and C. Okay, and then we have the set itself. And then the empty set. Okay, so this one here is our what? Our power set for y. So we've done part A. Okay, we've done part A. All right, and then the other thing there, they're saying find, this is B now. So find the power set of x intersection y. So to find the power set of x intersection y, it means we're finding the power set of x intersection y like this. So we can find this in two ways. Okay, we can find this in two ways. We can just intersect the power set of x and the power set of y, or we can first intersect this set y and x, okay, and then find the power set. So you can do whichever is easier for you, okay? But here, since we've already listed the power set of x and y, I'm just going to look for what is here and there. Okay, so I can see this set that contains a is in both. Okay, so I'll write it there in the intersection. The C, this guy here, is also in both. So I'll write it here, C. Okay, what else is common? I think the AC is common because I can see AC there and then AC. So I'll put the AC there. Okay. What else is common there? Okay. Nothing else. So it means the other set here just has to be the empty set like this. In fact, that set is common, right? Yes, yes, yes. All right. So yeah, so this is the intersection. I mean the power set of the intersection of x intersection y. Okay, so I'm done with that. Let's look at C. Okay, so C, they're saying find the cardinality of the power set of U, of X union Y. So we're finding the cardinality of the power set of X union Y like this. Okay, so these bars here just mean the cardinality of this. So how do you find the cardinality of the power set? Okay, we just first of all unionize whatever is there. So that is X union Y. So X union Y is going to be equals to, so I combine this and this without repeating anything. So that is A, B, C, and then D. Okay, so this is the union of X and Y, right? So to find the power set of this, I'll first have to find how many subsets is it going to have, right? So to find that, we said we do 2. Okay, we do 2 to the power what? N. And N is simply the number of elements there, which are 4. Okay, so here it's telling us that X union Y is going to have 16 subsets. Okay, X union Y is going to have 16 subsets. Now, when you talk about the power set of U, why am I saying U? Anyway, so when you talk about the power set of X union Y, okay, then we're talking about the set that will list all subsets of that guy. Okay, so it means in this set, we are going to list all the 16 subsets. Okay, but here, the question is not about listing all the 16 subsets. It's simply about the cardinality of this power set of X union Y. So the cardinality is simply the number of elements that are going to be in that set. So since this set is going to have 16 subsets, then how many elements are going to be there? There's going to be 16. So it means the cardinality of the power set of X union Y will just be this same thing that we are doing here. And it will just be 16. Okay, so don't write 16 subsets. No. Okay, the cardinality of the power set of X union Y is just 16. All right, so any questions there?
Please explain. I didn't understand anything. Start again.
Okay, where did you understand? Like we did part A, B, C. So you didn't understand A, B, C, you didn't understand anything?
No, part C. Part
Okay.
C.
All right, all right. Okay, so part C, we have been asked to find what we call as the cardinality. So maybe it's the term. You've seen this word cardinality here. So cardinality simply means the number of elements that are going to be in that set. That is cardinality. So if, for example, I had A, which had the following members, 1, 2, 3, and then they ask you, find the cardinality of A. Okay, you're just going to say the cardinality of A is going to be equals to, and then you count how many elements are there. So it will be 1, 2, 3. So I'm just going to say 3. So that's the cardinality of A, right? Okay, so I'm sure by now you've understood what cardinality is. And then now coming to our question, they're asking us to find the cardinality of the power set of X union Y. So they want us to find how many elements, okay, are in the power set of X union Y. Okay, so the other term that can confuse you there is also the power set. So what is the power set? Okay, so a power set is simply a set that contains all the subsets of a particular set. So if A is my set that I have been given, okay, so let's say A has 1 and 2. Okay, to find the number of subsets that A is going to have, we always use the formula 2 to the power n, where this n here is the number of elements in that particular set. So in this particular set, how many elements do you have? You just have 1, 2. So it will be 2 to the power 2, and 2 to the power 2 is going to be 4. Okay, so meaning set A will have 4 subsets, right? Okay, so now to find the power set of A, you write P of A like this. We're just going to say this is a set that contains all the subsets of this particular set A. So what are those, all the subsets of this particular set A? So a subset is simply a set that is a member of another big set. Okay, so from this set A here, one of its subset will just be if I get the 1 only like this. So this one will be a subset of that set. Okay, or if I get the 2 only, it will be the subset of that. Or if I get the set itself, everything, it will also be the subset. Okay, and then in our previous classes, we discussed that the empty set, okay, is always also a subset of any set that you can think of, including the empty set itself. So I'm going to put the empty set there. So you can now count the number of subsets that you have here. 1, 2, 3, 4. This is the 4 that I found using the formula, right? So now I brought it to simpler terms so that you understand. And then now we can go to the other one there. So now on the other one there, okay, they're saying find the cardinality of P, or I should say the power set of X union Y. So you first find X union Y. What is X union Y? Okay, X union Y, we are unionizing or combining this set here and this set without repeating anything. So that would be A, B, C, and then D. This is the union, okay? So I want to find the cardinality of the power set of this. So the first thing should be, I find the power set, okay? And then in that power set, I just count how many subsets are there. That would be the cardinality, okay? So now from here, I'll just say, okay, X union Y will have how many subsets? It will have 2 to the power. How many elements are here? 4. So I put 4, and that will just be 16 subsets. Okay? So X union Y has 16 subsets. So it means the power set of X union Y, here we can't list all the subsets because there are 16. There are a lot. Okay? There are a lot. So it means this set here, the power set of X union Y, is going to have all the subsets, all the 16 subsets of this set. So you can say the first one is A. I won't list everything, okay? The other one is B on itself. The other one is C on itself. The other one is D, okay? And then you start the pairing, A with what, A with what. Okay, so until you have 16 sets inside this set, which is the power set of X union Y, right? And then now they have added that cardinality. So now I'm just adding these bars here to say how many elements are going to be in this set here. So what do you do in order to find how many elements are here? Just simply count them, right? So I can count 1, 2, 3, 4, until there will be 16 of them, because this set here actually has what? 16 subsets. So no wonder here we're saying the cardinality of the power set of this X union Y is just going to be 16, because the power set of X union Y is going to have 16 subsets within it. Okay, I hope that is clear. The one who asked the question. Is that clear, sir?
Yes.
All right, all right, all right. Chipo, I've seen you raise the hand. You can ask.
So when finding the powers, the power sets, it's always
Mhm.
that we have to find the subsets also.
Yes, you have to know how many subsets are going to be here, and then now you find the power set because the power set will have the subset. So if you don't know how many, how are you going to find the power set?
Oh, okay, thank you.
Okay. All right, guys. So I hope you've understood this part. This question, you might find it somewhere, maybe in quiz 1 or in test 1. So just remember when you find it that we actually discussed this with Tutor Paul. All right. So I want to move to another part. So I want this video to be all right. So this question says let E be equals to, okay, so you can see the set that I've given us here now is in set builder notation form, right? It's in descriptive form. So they're saying let E, okay, be a set of all x's such that the x is an integer and this x is between 1 and 8, okay? And the 8 is actually included, and whatever this represents should be the universal set. Given that A, okay, is such that x is a member of the universal, okay, and x is a factor of 12. And then B, they have listed it, C, they have listed it, find the following sets that they have given there. Okay, so the first thing here to answer this one, we are going to remove these guys from the roster, from the set builder notation, these ones. We're going to represent them first of all in the what? In the roster form. And then once we have them in the roster form, all these here will just be what? We'll just be running over it. Okay, so the first one was that the universal set has been described as x being an integer, okay, such that this x is between 1 and 8. So which integers are between 1 and 8? 8 inclusive. Okay, it means the universal set here is just going to be 2, 3, 4, 5, 6, 7, and then 8. Okay, so we have shown it now in roster form. What about set A? Okay, so set A there, they're saying x is a member of the universal set. So meaning that whatever is going to be present in this set A should come from this universal here. Okay, so x is a universal set, it's a part of the universal set. Okay, and then x is a factor of 12. So what is a factor? Okay, when they say x is a factor of 12, what do they mean? Anyone? What do they mean when they say x is a factor of 12? Or when they say number is a factor of another number, what do they mean?
That simply means that number can go into 12 without leaving a remainder.
Okay, awesome. Yes, so meaning that we are looking for numbers in this universal set that are factors of 12. Okay, those are the numbers that are going to be in A. Okay, so which numbers here can go in 12 without leaving a remainder? Okay, the first one will be 2, 3, 4, 6, and that's all. So that is our set A. Okay, that is our set A. And then the other sets have already been given. Okay, so let me just write these on top there so that we have space down here. So the universal set, we've said it's 2, 3, 4, 5, 6, 7, and then 8. A is 2, 3, 4, 6, okay, and then B it's there, and then C is there. Okay, so the first one now they're saying find A minus C. Okay, so how can you find A minus C? Okay, so A minus C, in the other class I said this minus C is the same as A intersection C complement. Okay, but again, you can interpret it in this way. So if they say they want you to find A minus C without even finding this complement here, you can still get the answer here. Okay, so A minus C simply means whatever elements are common between set A and C, I have to remove them from the set. I have to remove them from the set A minus C. Okay, I should say that again. Whatever elements are common between A and C, I should remove them from the set A. Okay, I hope you've heard that. So here, I'm going to write the two sets. So this is set A. So set A has 2, 3, 4, and then 6, right? And then I'm going to say minus, and then I write set C. Set C is here. So that is 2, 4, and then 5. So in my definition, I said A minus C simply means the elements that are common between A and C, I should remove them from set A. Okay, so which ones are common there? I can see 2 and 4. They're also there. Okay, so I'll remove the 2 and 4 from this set A. That would be my answer. So to just be what? 3 and 6. So that's the answer there. Okay, but if you wanted, you can go the other way, where you first find the C complement, then you intersect it with A to still give you the same answer. Okay, so let's try. So C complement simply means all the elements that are not in C, but they're in the universal set. So C has 2, 4, 5. So from this universal set, I'm just going to remove 2, 4, 5. So I'm just going to remain with 3. Okay, 6, 7, and then 8. So this is my C complement. And then this C complement, I intersect with the A. What is common between the C complement here and the A? You can see that it's still 3 and 6. Okay. So in mathematics, there are a lot of ways in doing one thing. Okay, a lot of ways of doing one thing. So you can use that approach, or you can use this one that I've just shown you here. So that's the answer there. We forget about it. B, they're saying B minus A, and then intersection C. So here I'm going to use this approach because it's simpler. So in this case here, they've said B minus A. So meaning that they want, meaning that the common elements between B and A, I should remove them from the first set, which is B. Okay, so I'm going to write B here first. So B is 2, 3, 5, and then 6, minus A, which is 2, 3, and then 4, 6. Okay, whatever I get after I do this subtraction, okay, I should intersect it with the set C, which is 2, 4, and then 5. Okay, so let's start. So what is common between B and A? Okay, I can see 2, can see 3, can see 6, I can see 6. So whatever is common here, I remove them from the set B there. So if I remove whatever is common there, I'll just remain with 5. Okay, and then this intersection, the set C, which is 2, 4, and then 5. So what do I get here? Okay, I get 5. That's all. The answer is 5. Okay, but if you want, you can go the other way. You express this as B intersection A complement. Find A complement, you intersect, then you intersect with the C. There's nothing wrong with that. Okay, so meaning that this approach here that we are using, okay, you can only use it on countable sets. Okay, you can only use it on countable sets, meaning sets that you can count how many elements are here, right? You can use this notation that I'm teaching you here. But if it was interval notation, then you just have to find the complement. This won't work. Okay, you just have to find the complement. All right, let's look at the other one there, which is just, is that a De Morgan's law? I think so. So there we have A intersection C and then complement. Okay, so this one will just be, I first find my A intersection C. Okay. So, now we've erased the set A. Okay, what did we say A was? Okay, so A had 2, 3, 4, and then 6. So I'm intersecting this A with the C. Okay, so what is common? 2 is common, and then 4 is common. So that is A intersection C. Okay, and then now I'm not interested in the A intersection C. It's just going to help me find the answer. What I'm interested in is A intersection C complement. So I want now to find whatever elements are not here, but they're in the universal set. Okay. So remember the universal set E was starting at 2 all the way to 8. Okay. So I'll just remove 2 and 4 from the universal set. That would be a complement of A intersection C. So I'll have 3, 5, 6, 7, and then 8. Okay, so that's the answer there, guys. Any question?
I have
Okay.
a question.
Oh, yes. You can ask the question.
Sorry, it's on the previous one.
Mm-hmm.
Uh, um, I remember that in set B,
Mm-hmm.
And A,
Mm-hmm.
4 wasn't common,
4
but
wasn't
we
common.
only included, yes, but we only included that 5 wasn't common.
You're saying this question here on B.
Yes, the same one.
I've forgotten
For
now.
set A, we had
Uh-huh.
2, 3, 4, and 6.
Okay,
Then set B,
so for set B, we have 2, 3, 5, and 6. Then minus set
yes,
A. Set A had what?
2, 3, 4, and 6.
Okay, 2, 3, 4, and 6. Okay, and then we're intersecting
Uh,
this with C.
yes.
So now your question is about here, right?
Yes.
Mm-hmm.
We only got 5 as the element that's not common.
Uh-huh.
So
Okay.
can we include 4 too? Because it's not common in either in B and A.
No. You only focus on the set that is at the beginning here.
Okay.
Yes. So you don't focus what you are subtracting. No. Just focus on this part here.
Okay. Okay, thank you.
All right. Okay, so the next question there will be
I have a question.
okay.
There are the answer for A intersection C complement. You've
Mm-hmm.
included the 6, which is part of set A. How come?
Let me see. Okay, you're saying here I've included the 6 there, right?
The 6, yes, which is also in set A.
Uh-huh. So the only members that we are not including in that set are the members that are both in A and C. So now this is A here, and then C is 2, 4, and then 5. So you can see that the 6 is not both in A and C. So it means it will be in the complement of their intersection.
All right.
You haven't gotten it. So
I'm able to
first,
get that now. It seems like A6 is a C complement, but it's part of A, isn't it?
yes, it's part of A, but we are not interested in elements that are in the individual sets. No, we're interested in elements that are in the intersection of A and C. No wonder here we first found the A intersection C. You've seen this A intersection C. So meaning that now to
Yes.
find the complement, we are finding the elements that are not in this set here. No wonder I'm writing those. And the 6 is part of it because I can't see the 6 in the
All right.
intersection there. Oh, all right. There's
All
another
right.
question from someone.
It's all right.
All right. Okay, so I don't know which one now we are solving, but anyway. So the other one that we are solving here is, I'll leave the other ones for you guys. So this one here. So that is A intersection, and then I have B minus C. So let's write A. So my set A, okay, my set A, remember, was 2, okay, let me write it. So 2, 3, 4, and then 6. This was my set A. Then I'm intersecting this with whatever result I'm going to have here. So set B has 2, 3, 5, and 6, minus set C has 2, 4, and then 5. Okay, so that one was asking that why are you not including the members that are here? So when you're subtracting the countable sets like that, your focus should just be on the first set there. Okay, so I was saying B minus C is the same as, okay, we remove the elements that are common between B and C from the set B. Okay, so what is common between this B and this C? We see that what is common there is the 2, okay, and the 5. So I'm going to remove the 2 and the 5 from the first set here, okay, and not from there. Right, so what I'm going to have now is 2, 3, 4, and then 6, intersection. Okay, so from this set B, if I remove the 5 and the 2, I'll remain with 3 and 6. Okay, so now what is the intersection of this set A and this guy here? The intersection will just be 3 and 6. Okay, and that will be the answer there. So these things are easy. You just have to understand the basic concepts and then you continue with that. Okay, so the other ones there, you can try them out. So we can try out E, we can try out F, and then you can always consult with me if what you're doing is actually correct. Okay, so Mr. Daniel, you have a question.
Yeah, so my question is, this method that you showed, do they approve it during exams?
Yes,
Or
yes, it's
just making
approved.
sure.
It's approved as long as you're dealing with countable sets. So I've told you if you're dealing with intervals, don't use this one here. But if you're doing with countable sets, you can use it.
All right, thank you.
All right, all right. Okay, so let's look at another similar question here. You can see, so this one is basically on verifying some set laws. Okay, so we have a lot of laws that govern these topic sets. Okay, so they are called what? They are called laws of algebra of sets. Okay, so laws of algebra of sets. We have a lot of sets. I mean, we have a lot of laws. They are what we call as the independent laws. We are what we call as the De Morgan's laws, commutative, associative, distributive, and the set difference. Of course, the set difference you already know. Okay. We also have the properties of some complements. Okay, and then the properties of the universal and the intersection set. So that's what we call as the laws of algebra of sets. So here they have given us some sets and then they want us to verify something. Okay, so it's very easy. We just show that the right-hand side is actually the same as the left-hand side. So when we read the question here, they're saying let A be equals to this set, B be that set, C be that set, and then the universal set be from 1 all the way up to 10. Okay. All right, so the question now there is verify that A intersection B intersection C is actually the same as A intersection B and then intersection C. So this law here, okay, this law here is called as the associative law. Okay, so associative law simply means that it does not matter which pair you start with. okay, you are going to get the same answer. So you can see here, the pair that I'll start with is this thing that is in the brackets. So I'll start with the B intersection C. And then when I go to the right, I'll start with the A intersection B. But the answer that I'm going to get will just simply be the same. Okay, so here I have A intersection B intersection C. Okay, so I'm going to say A intersection. What is B intersection C? So I'm just looking for the common elements between B and C. Okay, so the common elements between B and C are what? So I can see 4 is also there. I can see 6 and 6 is also there. I can see 8 and 8 is also there. So 4, 6, 8. They are common. Okay, they are in the intersection of B and C. And then now I intersect this with A. So what am I going to get here? So this guy, I intersect it with A. So what is common between this and A is just a 4. Okay. We see if we are going to get the same thing. Is that true? No, I've left out the 6. Okay, so what is common between this and that is 4 and 6. So 4 and 6. So that's what I get on my left-hand side. Okay, when I start with this. What about here? When I start with the A intersection B, am I going to get something different? So A is here, B is there. So what is common between A and B? I can see 4 and 6. So only 4 and 6 is common. And then this 4 and 6 are intersected with C. So C has 1, okay? It has 4, it has 5, it has 6, and then it has 8. So what is common between these two sets here? We can see that 4 and 6, they're common. So I'm going to write 4, 6. So you can see that on the left-hand side here, okay, I found the same thing as the what? The right-hand side. So hence proved. Okay, hence proved there. So the left is the same as the right. So we've just proved the first associative law that has intersection. So we should also prove the other part, this one here now. So that one has intersection and intersection. Okay, so let's erase this. So for that one, I'm going to say the left-hand side is equals to A union B union C. So this is going to be equals to, okay. So my A, I'll just leave it. I'll just write A union. And then what is B union C? So B union C, we're getting everything that is in B and C, and then we're putting them together. So this is my B, and this is my C. So we get everything, we put it together. What are we going to have? Okay, that's what we're going to put in that set. So we're going to have a, okay, I'll just write these in order. So 1, 2, 4, 5, 6, 8, and then 10. Okay, so that is my B union C. You can see if I combine this set and this set without repeating anything, I'm simply going to have 1, 2, 4, 5, 6, 8, 9, 10. Okay, and then now this set here, I unionize it with the A. So A has 1, 3, 4, 6. Okay, the 1, 4, 6 is already here. So it means to this set, I just add the 3. So it will be 1, 2, 3, 4, 5, 6, 8, and then 10. Okay, so this is my right-hand side. What about, this is my left. So what about my right-hand side? So my right-hand side, I'm considering this now. So I'm starting with A union B. So A union B, and then union C. So this will be equals to, so let's find the union of A and B. So we combine everything there. We're going to get 1, 2, 3, 4, 6, and then 8, and then 10. Okay, then we're unionizing this with the C. So where's the C? So the C is here. So I'm unionizing this with this. So 1, 4, 5, 6, 8. So the 1, 4, 6, 8 is already here. What is missing is just the 5 there. So I'm just going to add the 5 to this. So it will be 1, 2, 3, 4, and then 5, 6, 8, and then 10. Okay, so this is my right-hand side. So now compare. Is this left-hand side, okay, the same as the right-hand side? The answer is yes. Okay, so we're going to say hence proved. Okay, so that's how we can prove the associative laws. Okay, that's how we can prove the associative laws. And then the other ones, okay, the other ones on B there, that's what we call as the distributive. So how do you identify the distributive laws? There's intersection and then union. Okay, intersection and then union. Then you're going to say, okay, this is distributive. But for the associative, if it's intersection, it will be intersection throughout, you can see there. And even here, if it's union, it will be union throughout. So that's how we can differentiate them. And then for the distributive, you're going to have both as a part of those. So let's prove part B. So again, there are two there, the distributive. So B, they're saying prove that this is actually equal to this. Okay, so A, or I'll say my left-hand side, which has A intersection B union C is equals to A intersection. So what is B union C? So B union C, I'm just combining here this with this. So that is 1. Okay, so that is 1, 2, 4, 5, 6, 8, and then 10. This is my B union C. Then I intersect this set with A. So what is common between this set here and the A? I can see 1 is common, 4 is common, and 6. So I'm just going to have 1, 4, and then 6. Okay, so that's what I get on my left. What about my right? So my right, I have this part. So I have A intersection B union A intersection C. So let's find A intersection B. So what is common between A and B? Okay, so there 4 and 6 are common. So 4 and 6, and then union. What is common between A and C? Okay, so A is this, and then C is that. So what is common there is 1, 4, and 6. So right here 1, 4, and 6. Okay, and then what is the union of this? We just combine everything without repeating any. So that is 1, 4, and 6. Okay, done. So you can see that right-hand side is actually equal to the left-hand side. Okay, so hence proved. Right, so any questions there, guys? Any questions that you may have there? Okay, I'm sure this is clear. So you can try out the other one there. You can try out the other one. So you can try out this part. Okay, I'll move to C. So what we have on C is what we call as the De Morgan's laws. So the De Morgan's laws are very vital because they can ask you to prove them. Okay, and there are two ways in which they can ask you to prove these. Okay, they're very common. You can prove them given sets, like here they have given us sets, right? And then you show that the right hand is basically the same as the left. Okay, or you can prove them using just arbitrary elements. Okay, you have not been given any sets, you can still prove the De Morgan's laws. All right, so let's try to prove one and then the other one we leave for you. So this one, I'm going to say my left-hand side, okay, for this part here, is A union B complement. Okay, so meaning that here, we're first going to find A union B. So A union B, it's 1, 2, 3, 4, 6, 8, and then 10. Okay, so now I don't want the A union B, I want a complement. So I can put a complement there. Okay, so complement simply means whatever is in the universal set, but is not appearing here. That's the complement. So here I have 1, 2, 3, 4. 5 is not appearing here. So it should be in the complement. 6 is there, 7 is not appearing, 8 is there, 9 is not appearing, and that's all. So in the complement of A union B complement, we're going to have 5, 7, and 9. So that is what I have on my left. What about my right-hand side? Okay, so my right-hand side, I have this. So I have A complement intersection B complement. So A complement is everything that is not in A. So I'll list everything that is not in A here. So A has 1, 3, 4, 6. So I'll list all the elements that are in the universal, but they are not in A. So that will be 2, 5, 7, 8, 9, and then 10. Okay, and then intersection, I now list B complement. So B has 2, 4, 6, 8, 10. So I'm going to list everything that is in the universal, but it's not in B. So that will be 1, 3, 5, 7, and then 9. Okay, and then we can simplify what now? We can simplify the intersection of that. Okay, so the intersection of that will be, I can see 5 in both, I can see 7 in both, and I can see 9 in both. Okay, so you can see that left-hand side is equals to what? Right-hand side. Okay, so you write here, since left-hand side is actually equals to the right-hand side, hence C, verified, or hence proved. Whichever word you choose. Okay, so any questions there, guys? Any questions that you have there? Okay, so if there are no questions, I can leave the other demogons though for you to prove, right? You just manage, right? So you can prove this one here. It's the same thing. So just write, I will find whatever will be on the left and then whatever will be on the right. All right, so moving on, I have this set of question now. So here they're saying the universal set is a set of all x's such that x is between 1 and 20 inclusive, and x is a natural number. So meaning the universal set, if we list it, it's just going to be 1 to 20. So 1, 2, 3, 4, 5, all the way up to 20. Okay. Set A has been given us a set of all x's such that x, okay, such that x is equals to 2 multiplied by k, and k is a natural number. So now, since the universal set is from 1 to 20, it means even A should just be from 1 to 20, should be within that same range. Okay, so if they are saying x is equals to 2k, and then the k is actually a natural number like this, it means I'll just start multiplying these natural numbers by 2. But whatever number I'm going to put in this set A should actually be within 1 and 20. So the first element to be in A will just be 2 multiplied by the first natural number there, because they said multiplied by k, and k is a natural number. So the first element in A will be 2, because it will be 2 multiplied by 1. What about 2 multiplied by 2 to be 4, by 3, 6, by 4, 8, by 5, 10, okay, by 6, 12, by 7, 14, by 8, 16, by 9, 18, by 10, 20, okay, by 11, we get 22, but we can't put 22 here because the universal set ends at 20. So we just end at 20 here like this. So this is my set A. Okay, so that is my set A there. What about what is the other set? The other set is B. Okay, the other set there is B. So set B, they're saying set B is a set of all x's such that x is equals to 2k plus 1 and k is the natural number. Okay, so I forgot to mention the other way to interpret this here. Since they're saying 2k, any number that you multiply by 2, it will just give you an even number. So here in simpler terms, I didn't mention it, but I'm mentioning it now. This set A is just a set of all even numbers between 1 and 20. Okay, and then for the set B, we're going to use that same shortcut. Okay, so here I said x is equals to 2k plus 1. So this 2k is an even number, right? And then to that even number, I add a 1. I'm going to make this an odd number. So meaning set B will just contain the odd numbers between 1 and 20. Okay, so simply meaning that the numbers that are not going to be what? In set A. So that would be 1, 3, 5, okay, 7, 9, 11, 13, 15, 17, and 19. Okay, this is what is going to be my set B. And then my set C has already been given there as 1, 2, 6, 8, 9, 11, and then 12, 15. Okay, and all these here are actually subset of the universal. So now the question is, find the following. Okay, so the first one on A is A complement intersection B complement. So this one, we can simplify it by the De Morgan's laws. We can say this one here is the same as A union B and then complement. So what have I done? I've just factorized the complement. So if I remove it from here, just remain with A. If you remove a complement from the intersection, we'll take it as that. We'll get the union. If I remove the complement from there, just B. So the complement now is outside there. Okay, so that it's easier to find. So A union. Oh, someone has a question?
Yes, so in sets B, if we follow the thingy here, there's 2k plus 1.
Yes.
So 2 times 1, that's 2 plus 1, that's 3. Why is 1 included in set B?
Oh, okay. I see your point. So 1 should not be there, right? Yeah. So 1 should not be there. 1 should not be there. Because if we put a 1 there, it will be 2, and then 2 plus 1, it will be 3. Yeah. So 1 should not be there. So we should start at 3. Okay. So thank you for that correction here. So here we're starting at 3 because 1 can't be there. Okay. All right. I hope I've corrected that. And then here now, we want to find the complement of A union B. So A union B, what do you think is the complement? The complement is just the number that you are from rubbing from set B. What is the complement? Hello? What would be the complement there of A union B? 1, ka? Yes. Okay, because if I write A union B, I'll combine everything that I can see here. And if I combine everything here, it's just the numbers 2 to 20. Only 1 will be left out. Okay, so I'm just going to say here, the answer there is just 1, like that. Okay, and then what's the next one? The next one, B. I have A union B. Intersection C. Okay, this is what I have. So A union B, okay, it's 1. Oh, not 1. It's 2, 3, 4, okay, 5, all the way to 19. This is our A union B, right? Then I'm intersecting with the C, which is 1, 2, 6, 8, 9, 11, and then 15. Okay, so what is common between A union B and C? Okay, so the 2 is common. You can put it there. Is the 6 common? Yes. Is the 8 common? Yes. Okay. Is the 9 common? Yes. Is the 11? Yes. 15? Yes. Okay, so the intersection there is 2, 6, 8, 9, 11, and 15. That's the intersection there. So any questions there? Okay, so if there are no questions, let's look at the next one. So the next one is C. Okay, so C, they've said A, okay, minus B union C. Okay, B union C. So here, we can just use that trick that we actually learned. It will work. But, okay, anyway, let's write the sets. So A is 2, 4, 6, 8, 10, 12, 14, 16, 18, and then 20. Okay, and then we're saying minus, so I'll just write the set down here, minus B union C. So B union C has numbers from what? From 2 all the way to 20, right? From 2 to 20. So 2, 3, 4, 5, all the way to 20. That is my B union C. So now, if there's a negative, if you are doing like the difference of two sets there, okay? If you want, you can find the complement, or you can use that one that we learned. So here, okay, I'm just, this part here is the same as removing the elements that are common between A and B union C from the set A, okay? Removing the elements that are common between A and B union C from the set A. Okay, so what numbers are common there?
Sorry. I have a question.
Yes, please. You can ask the question.
So where there's B union C, why are we not including one? Because in C there's one. So why are we not starting 1, 2, going up?
Oh, yeah. I thought that is A and yeah. I think I'm tired. I thought this is, I thought we are unionizing A and B. Because we are unionizing B and C. Okay. Okay, let me write the correct one. So that is 1, 2, 3. Let's just list them, everything. Okay, so 1, 2, 3. Do we have any 4 between B and C? No. So I'll go to 5, 6 is there, 7 is there, 8 is there, 9 is there. Do you have any 10? No. Go to 11, 13, 15, 17, and then 19. Okay, so this is the correct B union C now. All right, so now I was saying this set here is the same it's the same like we remove all the common elements, okay, between A and B union C from the set A. So what is common there? 2 is common, okay, 4 is not common, 6 is common, 8 is common, 10 is not common, 12 is not common, 14 is not common, 16 is not common, 18 is not common, 20 is not common. So I'm going to say A minus B union C, okay, is equals to, so I'm just removing these things that I've cancelled from A. So that will just be 4, 10, okay, 12, 14, 16, 18, and then 20. Okay, so this is going to be our answer there. So any questions there now? Any questions there? Okay, so if there are no questions, let's look at D. So D, that's what we call as the symmetric difference, because I can see the symbol for the symmetric difference. Okay, so that's that thing that is looking like a triangle, this guy here. So what is the symmetric difference? Okay, if I wrote A and then the symmetric difference with B, what is this? Okay, anyone who can help us. What is that? What would I write on my right-hand side? Hello?
Maybe A minus B.
A minus B. That's all.
Union B minus A.
Okay, yeah, so that's the symmetric difference. So we do A minus B, okay? And then on the other side, we say union B minus A. That's what it means, this symbol here. So now here we've been given A, okay, with symmetric difference with B union C. So meaning that this whole thing here is acting like this B here, okay? So it will just be A minus the B union C, which we're from finding on top there, okay? And then union B union C minus A. Okay, this is what I get here. So this answer here, we already got it here. Okay, so what did we get there? We got the set that had 4, 10, 12, 14, 16, 18, and 20, right? So this part here, we already got it from part C there. So that was it. Let me write it here. It was 4, 10, 12, 14, 16, 18, and then the 20. Okay, so this was the first part, this one. So meaning that we just have to find this other part here. Okay, so how do we find it? It's the same thing. So B union C. Okay, B union C.
Okay, B union C.
Someone has their mic on.
Tutor Paul.
Yes.
Yes.
Meanwhile, I'm sorry, but I think I've not gotten the. If you can restart.
Oh, like how we are coming up with
Oh, like how we are
the
coming up with
formula?
the formula?
Yes.
Okay.
Okay.
Okay, so on D, I've noticed, or as you can see this symbol here between these sets. That looks like a triangle. So that symbol is what we call as the symmetric difference of two sets. Okay, so by definition, whenever you have the symmetric difference of two sets, you're going to represent it like the way we have done here. Okay, so if I have A and then symmetric difference with the B, this here is the same as A minus B in brackets, okay, and then union B minus A. That is by definition, okay? Whenever I have A symmetric B, it is the same as that, okay? If I have other letters, for example, I have X symmetric difference with Y, this is just going to be X minus Y, and then union Y minus X. Okay, so that is by definition. So now, from that definition,
So,
you have a question?
Oh, you have a question?
yes, so there you mean it's A minus B union C
Where?
Where?
on the same on D.
Here.
Here.
No, on yes, when coming up with the formula, since you said it's like A minus B.
So here we have the A
So
there.
here we have the
Okay, then symmetric difference with the B union C. So this whole thing here, we take it as one thing. We're not taking it as two. No, we're taking it as one thing, like the way the B was there. So meaning that this part now, when I go to the right hand side, it's just going to be A minus this whole thing here. I'm taking it as one. No wonder I wrote here minus B union C, because I'm taking this as one thing, like the way the B was here. I don't know if you've gotten it now.
Yes, I've gotten it. Thank you.
All right, you're welcome. Okay, so now I was saying A minus B union C, we found it on C here, and it gave us this set. So meaning we can just use it directly because we already have it. And then union, and then now here I have to get this part. So B union C, okay, B union C was what? So let me just write it down here. So B union C, we combine this and this. So we had 1, 2, 3, 5, 6, 7, 8, 9, 11, 13, 15, 17, and then 19. So this is my B union C, and then minus A. So A is this guy here, which is 2, 4, 6, 8, 10, 12, 14, 16. I'm running out of space now. 18 and then 20. Okay. So now, since this is just the difference of countable sets, we said it's the same as we just remove the intersection of these two sets from the first set. So what is common between these two sets? I can see 2 is common, so I cancel it. What else is common? 6 is common, so I cancel it. 8 is common, so I cancel it. Okay, and that's all. Okay, that's all that is common. So meaning that I'm just going to remain with what? Okay, I'm going to remain with the I'm going to remain with the 1, 3, 5. Okay, and then I go to 9, 11, 13, 15, 17, and then 19. Okay, and that one now will help me find the answer now. So the answer to the A symmetric difference with this will just be the union of these two. So that would just be, okay, 1, 3, 4, 5, okay, 9, and then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20, which is just the same as the universal set. Okay, so that is the symmetric difference there. It's just the universal set according to our calculations. So any questions there, guys?
Why are you saying it's same as the universal set, yet we don't have 2?
Oh, we don't have 2? Yeah.
Yeah.
Oh, we don't have 2.
Mm.
Why? Okay, okay. Okay, I get what you're saying. So we don't have 2 there, so we can't call it as a universal set. I thought we had all the numbers there. Okay, so any questions there, guys? Any questions there? Okay, right. So this question here is on interval notation because I can see some intervals now. Okay, so they're saying, given that the universal set is a set of all real numbers. Okay, so meaning that the universal set is the set of all real numbers from minus infinity to positive infinity. Use the sets A, okay, which are from minus infinity to 2 union 4 to 8 inclusive, and the set B, which is minus 7 to positive infinity, to verify the De Morgan's laws. Okay, so here we're just verifying the De Morgan's laws using this. So the De Morgan's laws, there are 2. We have A intersection B complement, which is the same as A complement union B complement. So I'll do one, the other one you'll do. And then the other De Morgan's law is A union B complement. It's the same as A complement intersection B complement. Okay, so I'm going to do this second one here. All right, so here it means we need some straight lines or the number line. So I'll just draw the number line like that. So that will be my universal set there. So I've said the universal set is from minus infinity to positive what? Infinity. Okay, so that is my universal set. If you want, you can put some open circles at the end there to show that the infinities are not included. Okay, if you want, just leave it like that. There's no problem. Okay, so here we have A union B complement. Okay, so I'll put a 0 somewhere there. And then I'll plot, first of all, the A union B. And then from the A union B, I'll get the complement, right? Okay, so A is what? So A is from minus infinity to 2. So 2 can be somewhere there. 4 can be somewhere there, and then 8. Then the minus 7 can be somewhere there. Okay, so from minus infinity all the way to 2. That's the first part of set A. And 2 is not included, so I put an open circle. Here you can put just an arrow, meaning that still goes until forever. Union, and then now I start on 4 here. So I shade because there's a square bracket there on 4. And then I'm moving to the 8 here. Okay, I also shade there. Okay, so this part that I've shown on this number line is my set A. Okay, so this is A, and here it's still A. Okay, what about B? B is from minus 7 to positive infinity. So it's from minus 7 here all the way to positive infinity there. So I'll just write an arrow like that. And then on 7, minus 7, we're going to shade like that. So that is my B. Okay, that is my B. So now I want first of all to find the A union B. And then from the A union B, I can get the complement. Okay, from the A union B, I can get the complement. So what is the A union B here? Anyone who is seeing the A union B, what is the A union B here?
-7 to 8.
-7 to 8. Are you sure? A union B.
Okay.
Anyone who can try. What is the A union B?
Negative infinity to infinity.
Yes. Okay. So everything is covered.
Oh.
All the numbers there. Okay. They are either in A or they are either in B. So what is the complement now of what is the complement of the universal set, which is the set of all real numbers? What is the complement of this? To just be an empty set, right? Yes, so this is an empty set here because the A union B takes everything. It takes the set of all the real numbers. So meaning the complement of it is just the empty set. So you write A union B complement is just the empty set. Okay, so we've done this here. We were just doing the left-hand side here. So we also have to do the right-hand side, to see if it's going to give us an empty set again. Okay, so let's do that now. So I've shaded there my B and my A. Let me move these things here a bit on top like that. Okay, so I've shaded my A and I've also shaded my B, right? So from my B, I'm going to shade my B complement. So my B is from -7 here, you can see it, all the way to positive infinity. So my complement, it means on top here, I'm going to write an open circle because the -7 is in B, meaning in the complement, it's not there. So it's to start at -7 and then to go like this to minus infinity. Okay, so this is my B complement. Okay, what about my A complement? Okay, so my A complement, I will have two parts. There's this gap here. Okay, so the 2 is not included in A. So meaning it will be in the complement. So I'll shade there. And then I'll move to this point here. I'll not shade there. I'll put an open circle. So this here is the first part of A complement. And then the other part of A complement will start at 8. So here, open circle. And then I go to what? To positive infinity like that. So this is the other part of A complement. So Can we see any part of the A complement intersecting with the B complement? Can we see any part there? A complement intersecting with the B complement. We can't, right? There's no point where the A complement is overlapping with the B complement because the B complement is there. The A complement is here and there. So there's no point where they're intersecting. So it means that A complement intersection B complement is an empty set as well. So you can see that we've proved the De Morgan's laws using whatever we were given there. Okay, so any questions there?
I have a question just on the De Morgan's law.
Yes, you
I
ask.
don't understand how you come up with like why on the left hand side we have A intersection B complement, and then right hand side we have A complement union B complement. Like how you come up with that?
So it's just as simple. It's expanding the complement. So I have A union B and then complement, right? So what you do to come up with the other side, you just get this complement and distribute it to whatever you have inside. So this complement, when you take it to the A, it will give you a complement. This complement, when you take it to the union, it will change the union from the union to the intersection. Okay, so it becomes intersection. Then this complement, putting it on this B, to just be B complement. That's how we come up with them.
Okay, thank you.
Okay. All right. Next question. Oh, here I've left the other De Morgan's laws for you guys to prove on your own as practice. So me, I did this one, so you can do the other one on top there. Okay, so make sure you do it because these are the same things that are going to be coming in your assessments. Okay, and then here, okay, so here they're saying let X, okay, be the set minus 10 to 10, okay, be the universal set. So meaning it's the largest set that you have, right? And then let set A be, okay, from minus 2 to 7, and there are curved brackets there. Okay, B from minus 6 to 6, and their square brackets. Okay, so here, in fact, they've put union, and they have used some weird brackets there. So those are just used for listing. So let me put them here. So they've said B is actually equals to minus 6 to 6, and then they've said union. And then now you've seen the types of bracket that I've put there. They are the types of bracket that you have been used to when you are listing something. Like, for example, they give you set A has 1, 2, 3, this type of brackets here. So these types of brackets, actually, they are used for listing, okay? Listing the exact things that you can see inside them. So this is minus 6, comma 6, and then union 8 and 9, like that. Okay, so that is the set B. And then set C has been given as 3, comma 10. And then there's a square bracket like that. Okay, so the question says, find each of the following sets and display them on the number line. Okay, so now to answer such a type of questions, you are first going to display them on the number line and then find the set. So you do the opposite of what the question is telling you. Okay, the question says find each of the following sets and display them on the number line. So for you to answer it, you first display them on the number line and then you find the sets. Okay, so the first one there's a new concept that I need to explain. So there's C minus B. Okay, so whenever you see a minus between two sets, that's what we call as set difference. Okay, that's what we call set difference. So minus of a certain set is the same as, I would write C, and then this minus B, this one here, or it can be minus any set. It's the same as intersection B And then on this B, I add a complement like this. Okay, I hope you've gotten that. Whenever you have minus a certain set, this minus a certain set, for example, minus B, and then here there's also another set. It's the same as that set that is there. And then this minus B is the same as intersection B complement. Okay, so it's called the set difference. So for example, if I have again A minus B, this will be the same as A intersection B complement. If I have B minus A, it will be B intersection A complement. Okay, in short, minus a certain set means intersecting the complement of that set. Okay, so here for you to solve it, you first have to simplify it like we have done here. Say, okay, C minus B is the same as C intersection B complement. And then from there, you just have to draw now the number line. So on this number line, okay, carefully indicate the universal set that you've been given. So now look at the universal set here. We've been given from minus 10 to 10, and the minus 10 and 10 are actually included. So it means at the end of this universal set, we're going to have shaded parts like that. Okay, so this will be minus 10, and this will be 10. So this is my universal set. I've plotted it. Okay, and then I'll go to whatever I've been given there. So set C, okay, set C is 3 to 10, and then set B is minus 6 to 6, and then there's a union 8 and 9 there. Okay, so you should pay attention on this notation there. Okay, it was just put there to confuse you anyway, but we'll handle it. So I'll say, okay, let my 0 be somewhere there. Okay, and then my 3 should be somewhere there. My 6 should be somewhere there. Okay, so 6 there, 8 somewhere there, and then 9. Okay, what number I haven't plotted, which is in set C and B? Minus 6. So minus 6 can be there. All right, so let's first plot B. Okay, let's first plot B. So B, it's from minus 6, okay, to what? To 6. Okay, and then they say union 8 and 9. So this union 8 and 9, these types of brackets here, the carry bracket, are used to list. So union, it means you are putting something together, right? Okay, so union 8 and 9, I'm just going to put a shaded dot on 8 alone and on 9 alone, meaning that whatever is in between 8 and 9 or 6 and 8 is not actually a part of B. Okay, so these things that I've drawn here, there's this set interval notation from minus 6 to 6, and then there's this part 8 to 9. Okay, that will be my set what? My set B. Okay, that will be my set B. Okay, and then now let's get the complement, because this is my set B here. Let's get the complement. Okay, so the complement will be, I go at the end point here. I see that it's shaded there. Okay, so if it's shaded there, it means on top, I'm just going to write an open circle, and then I go to the beginning of this universal set. So here at the end here, okay, I'm going to shade like that as well. Why? Because the complement of B is actually a part of the universal set. Okay, so this is the first part of B complement. And then when I go to the other side, okay, be careful here because I have these 2 points that I need to remove again from the complement. So this is shaded, so I'll draw an open circle. Then I'll draw a line like this. And then as I pass at 8, 8 is a part of B. Okay, it's a part of B. So meaning that in the B complement, it won't be there. So I'll draw an open circle there. Then again, I go, 9 is a part of B, so it won't be in the what? In the B complement. And then I go all the way to what? To 10. So 10 is not a part of the set B. So meaning it's in the B complement, so I'm going to shade here. So this other part here is the what? The B complement as well. Okay, so now what I want to do is to intersect or to find where the line for the C and the B complement are actually what? Overlapping. Okay, so where are they overlapping? So my C is from 3 to 10. That is my C. So I'm just going to write that with maybe blue. Okay, so from from 3, which is here, you can see that on 3 there's curved, and then on 10 there's the closed one. So I'll just write a line first of all between the 3 and 10 like that. Okay, and then on 3 I'll put an open circle, and then on the 10 I'll put a shaded one like that. Okay, so now we're looking for the intersection between the B complement and the set C. Okay, we want the intersection between the B complement and the what? The C. So this one in blue is my C, and then this one here is my first part of the B complement. The other one is there. So I'm just looking for where these two are actually what? Intersecting. Okay, so where are they intersecting? Where is the blue line on top of the what? Of the green line? Okay, that's what we mean by overlapping. So these guys are actually overlapping starting from here. Okay, but there are those points that we are going to actually remove. Okay, so but they are overlapping there. So you can see that they are overlapping from, what is the end point here? From 6. Okay, and then all the way to what? To 10. But there's some two more breakpoints there, okay, because this guy here, 8 is not included, and the 9 is not included. So I'm going to say my C minus B is equals to C intersection B complement, which is equals to, so I'll start at my first point here, which is 6. So 6, you ask yourself now, is 6 in the C and is 6 in the B complement? Okay, so in the C, 6 is there because there's just a solid line like that, which is passing over C. This blue line here, solid lines passing over 6. So the 6 is there. But is the 6 in the B complement? No, because on the 6 in the B complement, there's an open circle. So it means there I'll just put an open brackets like that. Okay, and then I start moving, I have a breakpoint here. Okay, so that is 8. So I'm going to say comma 8, and then 8, of course, it's not in the B complement, so it's not in the intersection. So there will be a curve like that. Okay, but the set is still going. Okay, the set is still going. It does not it hasn't ended at 8 here. It's still going in front like that. So meaning that, how do we now combine with the other part? Okay, we're going to say union, and then again I'll start at 8, comma, where is the other breakpoint? It is at 9. So I'll write 9 there, curved bracket. Okay, and again the intersection is still going after the 9. Okay, but the 9 is not included. You can see that I've not included the 8, the 9 I've not included it. I'll just say union again, and then 9. Okay, from 9 it goes all the way to 10. So 10. So now at 10 you ask yourself, is the 10 a part of the C? We see that yes, it's a part of the C, because here at the end for the C it's shaded. And then is the 10 a part of the B complement? Yes, because here again it's what is shaded. So it means on the 10 I'm going to write a square bracket like that. So this set here is actually our C minus B, or C intersection B complement. Okay, so any questions there, guys? Okay, so if there are no questions, let's look at part B. So part B, we're going to do a similar thing. Oh, there's a
Hello.
question? Yes, sir.
Yeah, on the way you were plotting the code at the B complement, I didn't get that part.
The what?
When you were plotting at B complement.
The B complement. Oh,
Yeah.
okay. Okay, so look at the set B first. So what we've been given here, okay? What we've been given here on the B is that set B is the union of the interval from -6 to 6 inclusive. So this is the first part that I had plotted from -6 to 6, the B, okay? And then we are unionizing that with two numbers that are standalone numbers, these ones here, 8 and 9. So no wonder on 8, I put a dot. I put a shaded circle like that. And on 9, again, I put a shaded circle. Okay, because these ones are in list form. So I can't just extend the line like that. No, because the brackets there are actually these curly brackets used to list. Okay, so have you understood, first of all, how we've plotted the B before we go to the B complement?
Yes, I've understood on that part from
Uh-huh.
how you did. Uh-huh.
So now, when you want to get the B complement, I said you just go at the end point. Okay, so the first end point was this. I'm sure this part is not difficult. Okay, you just go on top. You ask yourself, is the -6 in the set B? Yes, because this is shaded. So it means in the B complement, the -6 won't be there. So I write an open circle like that, and then I go to the end of the universal set, or the beginning of the universal set, which is -10. Now, where there's a bit of thinking is on this side here, okay? Because there's some numbers that we actually listed there. So I go at the end point here on 6, okay? I ask myself, is 6 in the B? Yes. So it means in the B complement, it should not be there. So I draw an open circle there, okay? And then I start drawing a line going to the end of my universal set, which is -10. But I noticed that as I am going here, there's some numbers here, like 8 and 9, that are actually part of set B. So if these 8 and 9 are actually part of set B, it means in the B complement, they cannot be there. Okay, they cannot be there. No wonder here on 8 on top, you can see I was putting an open circle. Even on 9, I was putting an open circle as well. Okay, and then this other part continues, and it includes the last part of the universal set there. That's how we got the B complement.
Okay, thank you, sir.
All right. Okay, so now let's look at another question, which is B, or part B. We're simply using the same concept. Okay, we're simply using the same concept. So on B, they have said B minus A. I already explained what the minus means, right? And then intersection C. So B minus A is the same as B intersection A complement, okay, in brackets like that, and then intersection C. So in short, here they're telling us to find the part, okay, where B intersects A complement and also intersect the C, because it's B intersection A complement intersection C complement. So we are looking at the part where we're going to have an overlap of all these three sets. So let's draw a number line here, okay, and plot our universal set. So the universal set starts at -10 here. Okay, it ends at +10 there. Okay, and then there's A, B, and C here. So first, maybe we can start with the A complement. So I can just put a 0 somewhere in between, so that -2 can be there, and then 7 can be somewhere there. Okay, so let's plot the set A. So the set A is from -2 to 7, and the -2 and 7 are not included. So I'm just going to draw a straight line here. Okay, so the 2 is not included, I put an open circle. I mean the -2. And then the 7 again is not included, I put an open circle. So this part here that I've shown is my set A. But are we interested in the A? No. In the question here, there's A complement. So meaning I have to find the A complement. So how do I do that? I go at the end points. This is -2. So just on top of it, I shade now, because the -2 is not a part of A. So it means it's in the A complement, okay? Or it's outside A. And then I just go to the end point here, which is -10. So -10 is not in the A. So meaning it will be included in the A complement. No wonder I'm shading that last part there. Okay, so this part here is the first part of A complement. The other one starts here. Again, you ask yourself, is the 7 in A? No, because there's an open circle. So I'm going to shade for the complement. Then I move to the end point here. Okay, why am I including 10 in the A complement? Because it's not in the set A. So it has to be in the complement like that. So this here is the second part of A complement. So you can see we have two parts of the A complement, right? So now we want a part where this A complement intersects the B and intersect the what? The C. Okay, let's plot the B. So the B, where's the B? The B was from -6 to 6 and then union 8 and 9. Okay, so I'm going to say from -6 should be somewhere. Let's put -6 there. And then 6 should be before the 7. So I'll put it there. Okay, and then there's 8 and 9 like that. So I'm going to draw a line between -6 and 6 like that. Okay, so I'm going to include the -6 here because it's included in the set B there. And also the +6. Okay, and then union. Okay, what are other elements of this set B? 8 and 9. So on 8 here, I'll draw a line. I'll plot or I shade a circle. And on 9 again, I shade a circle like that. Okay, so this one is going to be tricky to understand, but just pay attention, you get it. So whatever I plotted in red here, okay, is my set B. Okay, so we have the A complement and we also have the what? The B. We are only remaining with the set C. So C is from from 3 to 10. So 3 should be between 0 and 6. So 3 is somewhere there, and then the 10 is there. So I'll just draw its set on top here. So I'll just say like this. Okay, so I ask myself now, is the 3 included? There's a curved here, so it's not included. So I'm going to say open circle like this. I have to get a pen. Okay, open circle like this. And then on the 10, there's this square bracket. So on the 10 is actually shaded like this. So this set that I've drawn on top there is my set what? C. Okay, so now the question demands that I should look for a point, okay, where the set B, the set A complement, and the set C are actually overlapping each other, like they are on top of each other. Okay, so which point can we see there that overlaps all the three? Anyone who can try. Anyone who can try. Which points are overlapping all the three sets, the B, the A complement, and the C? You can't see them. Oh, GP.
It's
Go on.
-2 and 6.
Minus what?
-2 to 6.
Okay. Anyone else? Where are the three sets overlapping? C, B, and A complement.
3 and 6.
3 and 6. Someone said 3 and 6.
-2
Okay.
to 7.
-2 to 7.
No.
You guys, I need, okay. It's that at this point here, there are some points. So for example, this is a line for C. This is a line for B. And then this is a line for A complement. So I need a point where like three things are overlapping like this. That's the answer because we are looking for the intersection. Okay?
I think the answer is an empty set.
It's an empty set.
How could it be? It's not even overlapping. It's not
Okay, so
overlapping.
6.
so like
I
an
tried.
interval. Oh, yeah. Maybe you can get the answer.
Okay,
I'm
3
saying
and
that
6.
that
That's it.
independent 8 and 9.
So that's the answer, guys. You can see that
Mhm.
this, like on this 8, you've seen this 8 here and this
Mm.
9 here. Okay, it's first of all part of set B because I've shaded them in red. So it's part of set B. And then on top of it, C passes like that. So meaning 8 is also in C on top here. 9 is also in C. And then A complement, it means again here as the A complement goes like that. Somewhere here there's 8 and somewhere there's 9. So the numbers that are in all the three sets that we actually described is just 8 and 9. That's all. Someone
Mm.
didn't see it. I hope you've seen it. You've seen it? Have we all seen it? That it's 8 and 9.
Mm.
Yes.
Yes.
Okay. All right. I'm very happy if you have actually seen it. Okay. So if you can see these ones that are independent, then the ones that are in interval form should not be of any difficult. Okay, because they'll just be a straight line, and then you'll see, okay, from this line and this line, they're actually overlapping. Okay. So here the only numbers that will be present in these three sets will just be 8 and 9. And because it's just 8 and 9, it means you're just listing them. You're going to use these two curly brackets there. So it will be 8 and then 9. This is the only intersection. Okay, so this is a tricky question on set interval notation, but I'm happy that actually someone saw it. Okay, let's look at, is that part C now? Okay, so part C is very simple because it's straightforward and it does not include the hard set B. Okay, so on part C, we have A intersection C in brackets and then a complement like that. Okay, so this one here is a special rule under sets, is one of what we call as the De Morgan's laws. Okay, it's one of the De Morgan's laws. So meaning that you can actually represent this in another way. So I can just get this complement here and take it inside there. So this complement to the A, I get a complement. The complement to the intersection, I get union. Complement to the C, I get C complement. Okay, so at some point, you'll be actually asked to prove that this is equals to this. Okay, but that's the story for another day. Okay, but here I'm just showing you that you can actually simplify it like that. Okay, so if we plot this on the number line or plot this on the number line, it's going to be the exact thing. Okay, but which one is easier? The one which is easier is this one to plot. Okay, because this one you have to find the complements of the two sets and then you get their union. So it will take a lot of time. So, but this one is the simpler one. So let's actually plot it and then find the set. Okay, so we have a number line like that. Okay, and the universal set here is from -10 to +10 there. And the -10 is included, so I'm shading it, and the +10 there is actually included. Okay, so where is my A intersection C? So I'll put 0 somewhere there. My A is -2 to 7, and then my C is 3 to 10. So meaning that my A starts at -2 all the way to 7 like that. Okay, so here we have a curved bracket like that. So we'll put open circle. And then 7, we also have a curved, so we'll put open circle like that. Okay, so this is my set A. And then for the set C, we are moving from 3 to 10 like that. Okay, but 3, we do not include it. Okay, because there's a curve there. And then on 10, okay, there's a square, so I have to include it like that. So this here is my part C. Okay, so now I need to find the set C intersection C complement. Okay, I need to find the part A intersection C complement. So what I need to do first of all is actually identify my intersection. Okay, so where is the A and the C intersecting? You just look at the point where the line for the C and the line of the A will be on top of each other like that. So we see that that part will just be which one? It will be which one? Let's try to answer this.
3 and 7.
Exactly. Okay, so this one is straightforward. So it is between this. Okay, so this is the intersection there. Okay, so we can even first write the intersection down here. Okay, so the intersection of A and C is actually from 3 to 7. Okay, and then now you can judge the type of brackets. So 3 is not included in C. Okay, so meaning it's not common. So I'll just put curved. 7 is not included in A, meaning it's not common. So I'll just put bracket like that. But this one here is not my goal. My goal is to find its complement. Okay, so meaning that all the other elements that are not actually a part of this part that we've shaded in red. So we're going to represent that with the black. Okay, so meaning I'll go at the end point 3. Ask myself, is the 3 in the A intersection C? The answer is no, because it's open. So I'll shade on top like that. So I'll shade like that. Okay, and then I'll go to the left like this, all the way to the 10 there. So the 10 is included, yes, because it's not in the intersection. So this here is the first part of A intersection C complement. Okay, the other part will start at 7. So 7 is not included in the A intersection C, meaning that it should be included in their complement. And then we draw a line going to the what? To the 10 there. And the 10 will be included. So this other part that I've drawn is my other part of A intersection C complement like that. Okay, so that is what I have. So meaning that my answer will just be a union of those two. Okay, so I'll say A intersection C complement now is equals to, I have two parts. I have this one from -10 to 3. Okay, and I'll put here, what types of brackets am I going to put here? Here is shaded, here it's shaded. So it's included, so it will be square. Okay, when I come at 3, it's also shaded there. So I'll just put a square like that. Okay, and then there's this jump now to exclude the A intersection C. So I'm just going to say union, and then I'm starting at 7 all the way to what? To 10 like this. Okay, so this one here is my A intersection C complement. Okay, meaning the elements that are not a part of A intersection C. Okay, so any questions there, guys? Any questions there? Okay, so if there are no questions, I'll move on to the next one. Okay, but I want to leave some of these ones for you guys. So which one looks the most difficult? I think E looks the most difficult. So let's solve E. And then you can try out D and F. We see if you actually understood whatever we are doing. Okay, so I'll solve this E. And then try out D and F to see if you've understood what we are doing. So on E, look at the set first, what the set that we have. We have X, which they said was the universal set, okay, minus C in brackets and then complement. Intersection A minus B. Okay, so before we can answer this, we need to simplify this set. So we said whenever there's a minus something, it's just intersecting the complement of it, right? So this will be, okay, X intersecting C complement. Okay, in brackets like this, and then complement outside. Maybe I should be using the same symbol for the complement. So this is complement, and then again complement. And then intersecting, this will be A. This minus B. It's the same as intersecting B complement like that, right? Okay, so now here, in this first bracket here, there's a very special property that I want to bring to your attention. So X represents the universal set, right? And the universal set has been given from -10 to 10, okay? And then C is from 3 to 10. So what will be in the C complement? It will just be everything from minus 10 to 3. Okay? And then I'm intersecting now the whole set, which is the universal set, minus 10 to 10. I'm intersecting with the complement of C. What do you think I'm going to get just inside here? If I'm intersecting the universal set with any set, what do I get? Hello, guys. If I'm intersecting the universal set with any set, what do I get?
Any set, get there.
I get the what?
It's the universal set.
It's the universal set intersecting. Are you sure?
If you are intersecting C with the universal set, you get C. Yes, you
Exactly.
get C.
Okay. So you get the C complement itself because this guy here is the universal set. So if we were to draw a picture, it would look something like this. So let's say this is my universal set, right? Okay. So it means all the other sets, because this is the universal set, all the other sets are going to be part of the universal set. Okay. So if this is my set C, my set C complement will be everything that is outside C here. That's why I have my C complement. Now, I want to intersect the C complement, okay, with the universal set. I'm just going to get the C complement itself. So inside the brackets here, universal intersecting C complement is just going to give me C complement. And then I still have that complement outside and then intersecting, okay, A intersecting B complement like that. Okay, so that is what I have there. Okay, and then now I can expand the complement. So complement multiplied by the complement is going to cancel. So I'm just going to remain with C, intersecting A, intersecting B, complement like that. So now this here is a simplified set that we can easily plot on the number line, and then we find whatever it will compose of. Okay, so let's write it here. So this guy actually simplifies to C, intersecting A, intersection B, complement like this. Okay, I hope you followed how we did it. So now let's just plot this on the number line. Okay, so our number line is like this. Okay, so I have from minus 10 to positive 10. Okay, and then I can put 0 somewhere there. Okay, so this is C intersecting A intersecting B complement. So what am I going to do? Okay, I'll first plot C. Let's plot C. So C is from 3 to 10. So 3 to 10. So there, that's my C. So the 3 is not included. The 10 is actually included like this. Okay, so this is my set C. Okay, what about my A? My A is from minus 2 to 7. So 7 can be somewhere there, minus 2 somewhere there. So I'll just draw a line. So let me put this in green, like this. Okay, so minus 2, open, because there's a curved. 7, open. So this is my A. Okay, so I've plotted the set A and the set C. I'm just remaining with the B complement. Okay, so the B complement, we first start with the B itself. So the B itself, it's from minus 6, which can be somewhere there, to 6, which should be between 3 and 7. So somewhere there. Okay, so to be somewhere there. And the minus 6 is included, so you can see I'm shading it. Okay, and also the 6 is also a part of it. So this one, I'm also shading it like that. Okay, but is that all for the B? The answer is no, because for the B, we also have union 8 and 9. So there should be 8 somewhere there and 9. And this 8 is actually a part of set B. And the 9 is also a part of set B like that. Okay, so that is my set B. This whole thing and then 8 and 9. All right, so now we're just interested in the complement of B. So this one is included in B, meaning in the B complement won't be there. And then it goes to the end The minus 10 is still there. This is the first part of B complement. Okay. The other B complement starts here. So the 6 is not included, and then I draw a line. The 8 is part of B. So in the B complement, it won't be there. Okay. Again, the 9 is part of B, meaning the B complement, it won't be there. So I'll draw an open circle, and then I go all the way to what? To 10 like that. Okay, so that there is my other part of the B complement. So now this question here demands that I find the intersection for C intersecting A intersecting B complement. So for the B complement, I have it there and there. And then for the A, it's there. And then for the C, it's there. So where is the intersection of the B complement, the A, and the C? Anyone who can see it there. Where is the intersection?
Um, 3 and 6.
You said what? Did you say 3 and 6?
Yes.
6 and 7.
Yeah, so the correct one should be 6 and 7.
7.
So you can see here, per 6 hapa. You come down and the 7 there. So if I shade those guys, you can see there's B complement, there's a bit of A, and there's a bit of C, this one here. Okay, so that part covers for the 3 sets that we are looking for. So I just go at the end points now. So here I'm going to say is equals to, so I have 6, 7. Now, how do we decide the type of brackets that we're going to actually put at the end there? Okay, so you just come at 6 here. You check if 6 is in C, it's in A, and it's in B complement. Okay, so is it in C? C, yes, it's in C. Okay, is it in A? Yes, because they are just solid lines passing through 6. Is it in B complement? No, because in B complement, there's this open circle there. So it means the 6 is not common. So I'm going to draw a curved like that. Then I go at the other end point, which is 7. Okay, 7 is in 6. Yes, it's not in A. So if it's not in one of them, then it's not common. So I just say close there. So that one there will be my answer. Okay, so yeah, so that's how we do the set interval notation. As I already told you, there are more videos on YouTube. You can find them. And also on our website, we have a lot of the videos, okay, that you can actually use to practice and learn at your own pace, at your own time. All right, so any questions, guys? I've left these others here for you to try them out at your own time. We have this one, we covered it last week, so I'm not going to solve it again. The video is already there. Okay, I'll move on to the next one. This one here. Okay, I think this one here will be the last question. Okay, so here they're saying given that the set of real numbers is the universal set. Okay, given that set of real numbers is the universal set, so U is just the set of real numbers from minus infinity all the way to positive infinity. Okay, and A is minus infinity to 7 inclusive, union 9 to positive infinity. B is from 5 inclusive to positive infinity. Find each of the following and show them on the number line. Okay, so I already said that when you have such a question, you do the opposite. You show them on the number line and then you find the set. Okay, because there is no way you can find the set without showing them on the number line. Okay, so what we're going to do here is that we're just going to write the universal, okay, which is from minus infinity. Okay, it's from minus infinity to positive infinity like that. So I can put a 0 somewhere in between. So the first thing that they are asking is to find A complement. Okay, so first plot A. So A is from minus infinity to 7. So minus infinity is there to somewhere 7. So 7, we can put it somewhere there. Okay, and then it starts at 9 all the way to infinity. So 9 can start from there all the way to infinity like that. Okay, so here just put an arrow like that. On 7, there's a square bracket. So meaning I'm going to shade there like that. Okay, I can put a 7 there. Here I can put a 9. And here there's a curved bracket. So this will be open like that. Okay, then here I can put the arrow. So what I've plotted there is A. So meaning what is A complement? Okay, so A complement will just be this part here. So on the 7, I'll put an open circle. On the 9, I'll put a shaded circle like that. So this part here will be my A complement. Okay, that's all. So that is my A complement there. So you can even shade it like that. So now, writing the answer, you say A complement is equals to, so it's between 7 and 9. And then you ask yourself, is the 7 included? The 7, no, because there's an open circle there. So put a curved bracket. Is the 9 included? Yes, because it's shaded there. Okay, so I put a square bracket like that. So that is my A complement, 7, 9 like that. Okay, any questions there? Okay, we move to A union B complement. Okay, A union B complement. It means we first have to show the A union B and then we get its complement. Okay, so whatever I'm showing here, it's my A. Okay, so this is my A. Then what is my B? My B is from 5 to positive infinity. So 5 is somewhere there to positive infinity. So 5 to positive infinity like that. So meaning that here the arrow still goes, 5 is included. Okay, so what is my A union B? If this is my B here and then my A is there, what is my A union B? Can we see the A union B?
Maybe from 7 to from 5 to 7.
A union B.
Negative infinity to positive infinity.
Yes, because union you get everything. So everything that is in A, combine it with everything that is in B. So you can see that every number here, it's either it's in B, it's in both, or it's just in A. So A union B is the whole set here, okay, of real numbers. So meaning that A union B complement will just be the empty set, okay, because the union gets everything. Okay, I'm done with that. C, they're saying A minus B. So here now, don't use that trick that we are learning on the countable sets, okay? So here we just have to draw, and we have to represent this as A intersection B complement. So my A is already here. My B complement is going to start from here, okay? And then it goes like this. So I'm intersecting A with the B complement. So this is the B complement here. So you can see where the overlapping is from minus infinity all the way to what? To this 5 here. Okay, so now you ask yourself, is the 5 included or is it not included? Because we know for the negative infinity, it's always not included. So the 5, okay, is it in A and is it in B complement? No, it is in A, yes, but in B complement there's an open circle. So it's not common between them. So I'll just write 5 and then a closed curve like that. So that is our A minus B. Any questions there? Okay, so if there are no questions, let's look at the last one, which is what now? So B complement. Maybe I should leave this first. This thing can lead me to the answer. Okay, so the last one there, they're saying B complement intersection A minus C, B. So A minus B is this, and then we are intersecting it with B complement. Okay, so A minus B, which is the same as A intersection B complement, is this part that I've shaded in red here. So now, we want to intersect this part that I've shaded in red with the B complement. What answer am I going to get? Hello? What else am I going to get? If I intersect this
Negative
shaded part,
infinity to 5.
negative infinity to what?
To 5.
Yes, okay. Because this part here is minus infinity to 5. B complement is also minus infinity to 5. So we just get minus infinity to 5 as well. So there's even nothing to do there. All right, guys. So I think for today we can end there. Unless you guys have any other questions that you want to ask. Okay, so meaning we'll end here. We'll continue. I think we are done with the sets parts now for this tutorial sheet. We are done. So the other time now we'll start looking at things like the irrational numbers, how to prove them, SADs, how to simplify them, rationalize the denominator, to start looking at that. Okay, but those who are subscribed, I've actually already solved the other questions there, so you can access them from the website or the mobile app. And on the mobile app, you can also download them in case you are staying at a place where there's like low internet connectivity and the like. You can download when you go to campus where there's network. Okay, you download in advance, and then you can watch offline on the mobile app. All right, so thank you so much, guys, for attending the class. I hope you've actually learned how to solve the questions on the sets. The free life classes are ending after tomorrow. So tomorrow is Friday. Saturday is the last day. So if you want to continue learning with us, you can subscribe. So how to subscribe? There's a link that I'll share in the group. Okay. For those who will be watching this on YouTube, there's a link in the description below. So make sure you just click on the link. You watch how to subscribe and then you subscribe. All right, guys, have a blessed night.
Thank you.